Thank you for purchasing the Small Block Chevrolet comprehensive engine rebuild video that we have put together for you. I have been an automotive engine machinist for nearly 35 years. I have built thousands of small block Chevrolet engines. And so before we get started, I wanted to reiterate the fact that you are going to get an email address that you can actually email me personally and ask questions if you have any. We are setting that up exclusively for those of you who have purchased this program. And also a couple of things, if you are building a 400 small block, a 283 small block, or anything in between, it's important that you understand that pretty much everything in this video is geared to any small block Chevy. The cubic inch size does not matter. I get customers quite often that will say, you know, you should do something on the 400 small block instead of just the 350. I just say, why? It's the exact same process. The only difference between the small block Chevrolets cubic inch wise was the bore and the stroke. Pretty much every small block Chevrolet from 1955 up to 2000, all these principles and these practices are going to apply. Now, there were some differences over the years and some changes, and we're going to talk about that stuff, but the basic engine itself has not changed in 60 years. So I hope this helps you. We are here. We are committed to your success. We want you to successfully be able to build your own small block Chevrolet with the help of your local machine shop. So I want to walk you all the way through the process, all the way from an engine that just has a ton of miles on it and needs to be torn down, all the way from the core through a complete running rebuild. I believe it's well worth the money. We put a lot of time and effort and energy into this. And also, one thing that will help you is the index that we have. If you want to skip ahead or go back to a certain procedure or section, that index is invaluable. It gives you the ticker number of where in the video this particular subject is being covered. But I would advise you to, if you're building your engine, that you would follow along step by step as you go through this. I mean, you can watch the whole thing through if you like, but this video is basically designed so that you can do a step-by-step rebuild successfully from start to finish. And honestly, you guys, this is geared for somebody who has actually never built an engine before. It also is good information for people who have some experience but really need a little bit of guidance in what they're doing to really make a good solid power. So let's get into this, and I think you're going to enjoy it.
So I wanted to show you this ring compressor tool. Now originally, for many years, I would use the band style expandable type ring compressor, and these work okay. But sometimes what happens is the rings will slip out the bottom of them, and if you don't get it just the right amount of tension on it, these are more problematic. And I've actually in the past broken some rings and stuff putting them in with the band type or the expandable type. So this is what I was just talking about. Now this is made by Total Seal. They actually manufacture these. And this is a cone style ring compressor, and it is literally a cone. The thing about this type of ring compressor is you have to have one for every size of bore. In other words, it's a fixed diameter here. So this is one that I just had them make up for our 305 build. Every time I do a bore size that I haven't done before, I usually have them go ahead and make one of these for me because the price is pretty reasonable, right around like $69, $70, somewhere in there. So that's not bad. I don't know how feasible that is if you're just doing one engine. Personally, I think it's money well spent. Once you use one of these, the thing is you'll never really want to go back. So that's one of the tools that we use. Another one is straight edge. Now, straight edge is also something that you're going to want to get. If you're into doing this yourself, you got to get yourself a precision straight edge. Now this is not just some random piece of steel. This is a precision machined edge here, and it is machined to within like 3/10,000ths of an inch all the way across, so it's perfectly flat. So it gives you a standard, so when you lay this on the head, if there's any distortion or warpage, you'll be able to take a set of filler gauges and you'll be able to slide it in there, and it tells you whether or not the head or the block needs to be resurfaced. So straight edge, a really good tool. Another one here for the rings is you need to get yourself a good set of ring pliers. Now, rings are not ever to be rolled onto the piston. So in other words, A lot of guys will take the ring and they'll get one side of the ring started here, and then they'll just kind of twist the ring and roll it on there. There's not a ring manufacturer in the world that says that that's okay. Now, I know some guys have done it and they can get away with it, but these are steel or cast iron rings, and most ring manufacturers, including Total Seal, which is the biggest ring manufacturer in the world, will tell you that it's not a good idea to twist these steel or cast iron rings because it fatigues the ring and it shortens the life of the ring. So we want to use ring pliers to take those on and off, and that keeps the ring level. We expand it. It's a ring expander plier, and we put it on so it's level. So ring expander pliers, great tool, one that I recommend for your toolbox for engine building. Of course, a good set of micrometers is something that you need to have, right? If you're going to do any precision measuring at all, you have to have some micrometers, and there's a lot of different sizes of mics depending on what you're building. So you definitely want to buy a good quality set of mics. If you're going to do cam profiling, or you want to know what your lift is, this is a lifter bore gauge. Now, it just uses a regular dial indicator, and this tool was actually manufactured and sold by a place called Powerhouse. Actually, I don't know if they manufactured it, but they sell it. A lot of these specialty tools you can get online, and there's a company by the name of Powerhouse, and they have all of these tools. This goes in the lifter bore, and there's a couple of different sizes here. You can tell them what size lifter bore you have. This is a universal deal. This is a small block Chevy lifter bore, and this is a small block Ford lifter bore. And there's several other bores that are universal to this. You just put that in and you rotate your cam lobe, and as the cam lobe rides up on the profile, it tells you what the lift of your cam is. And that's something that you will probably need to know if you're degreeing a cam, or you have a mystery cam and you don't really know what it is. The lift of your cam is really important. Another one is a deck gauge. Now, this is a gauge that sits over the cylinder, and I bring my piston up to TDC, and this will tell me what my deck clearance is, or how far down in the bore my piston is sitting. Again, Powerhouse. Get online, go to their website, and they sell this stuff. When I bought this, I just purchased, it didn't come with the indicator. I purchased this billet anodized piece here, and you just put just a standard dial indicator in there. That thing comes out. You just put your dial indicator in there, and you tighten it up, and there you go. You can, and it's a little bit, you can adjust that wherever you need it. And also, if you need to get over on one side, you can put the indicator over here. If you need to measure something on this side. So it's a real handy piece, and it also is magnetic back here. So once you put it on the block, it sticks to the block. Powerhouse, great tool to have if you need to check your deck clearance or things like that. For measuring bore diameters, I recommend a dial bore gauge. Now, you don't have to spend tons of money on one of these. This is actually one of the less expensive ones that's out there. You can buy this. I bought this on eBay, I believe. I have 2 or 3 of these, and I bought them on eBay, and it's been so many years since I got this that I don't remember exactly what the site was, but if you just do a search for dial bore gauge, you'll see a bunch of these come up, and I think I paid $80 or $100 or something for this, and it did come with the indicator. And again, the indicator comes out, it's adjustable, it has all kinds of attachments and so forth for different bore sizes, and this is a great tool for checking rod bores, cylinder bores, main bores, oil clearances. Fantastic. This is invaluable. You really need to have. One other thing that I would like to mention here is that you need to get yourself a good torque wrench. This is a digital torque wrench. You don't have to have a digital torque wrench. There's some good click type. There's even some decent beam type torque wrenches out there. I have a beam type torque wrench that was made by Craftsman, and I've had it for probably 20 years. And I have checked it repeatedly over the years against digital torque wrenches and against click type torque wrenches that I had calibrated, and it's always right on the money. So one of the things that you have to do if you have a click type torque wrench or like a dial indicator type torque wrench is periodically you need to send that torque wrench out to like a small tool repair shop, a precision tool repair shop, and you have to have them calibrate that tool, and then they put a calibration sticker on it. The nice thing about some of the digital stuff is they are self-calibrating, like this one here. Snap-on has great stuff. This one here is made by Craftsman, and this thing goes up to like 250 pounds. I actually bought this exclusively for one job. I was doing a diesel engine that had really high torque on it, and I didn't have a torque wrench that went that high. It was like 240 foot-pounds on the bolts, and I bought this thing, and I paid, I think, $150 for it. And I love this torque wrench. This thing is really nice. So you got to have good quality tools. It's important that you don't skimp on this, because having the right tool for the job is a big issue. So if you have any questions on any of this stuff, or you want to know where I got any of this stuff, or you want sources for it, just let me know, ask. I know during the builds we burn through this stuff and we say, hey, use this tool or use that tool. It's a good idea to kind of give you a little bit of insight on this stuff, I think, and why we actually need this stuff. With engines, we're dealing with precision, we're dealing with clearances and stuff are literally as thin as a human hair. You cannot eyeball that stuff. You actually have to have really good precision measuring tools in order to get those clearances and tolerances correct, or make sure they're correct. That's part of the inspection process, is using precision tools.
And we're going to put this in here, and the difference that we see will be our oil clearance. I'm going to go back and do it again. And go back up to the top, and I'm going to go backwards down past 50. Once you get the reading on the micrometer, go ahead, there's a locking mechanism on here. We'll just gently lock that. You don't want to get too crazy with this. We don't want to damage the crank. And then we're going to read our micrometer. Sure that we can't pull that out of there. All along the surface. And this looks really good. Back again. So today we have a engine that we're going to tear down. This is a 350 Chevy. It's just a core that we picked up. You can pick these up on Craigslist or wrecking yards, or a lot of different sources or suppliers. We picked up our core for $200, and one of the main reasons we bought this one is because it has a roller cam in it. This is what they call a TBI, throttle body injection engine. We will probably end up putting Vortec heads on this, however. So once you get the core purchased, look at the casting number. This one has a casting number that denotes that it's a 350. So we were pretty concerned to make sure that we got a 350 rather than a 305. So this is a 350 engine. The next step, after you get the core purchased, get it back to your shop or your garage or whatever, we want to get this thing up on an engine stand. But the one thing that you want to look for is these pedestals in here that have tapped and drilled holes. That means that the block is compatible for a roller cam. So you can upgrade this and put a factory roller in it for a pretty decent price. And it also has, the center bolt valve covers. We know that this thing was running because I bought it from a friend of mine who pulled it out of the truck. And one of the things you want to look for back here, now this is a one-piece rear main seal block, and the seal housing was missing, so we're going to have to get one of those. But when you buy one of these, you want to look on the left-hand side of the motor back here and make sure that it says 5.7 liter. It is possible you could get one of these that says 5.0. They're really hard to tell apart, so you don't really want to get the 305. So you can see, if you look right here, this says 5.7 liter. That's what you're after. And so I'm going to go ahead and take this apart. One of the things that I would say is you really need to have, a good local machine shop that can help you get everything cleaned up, possibly machining or whatever it needs. All right, so the next step is we'll get the valve covers and the heads off and see what we're looking at inside this thing. All right, so I got the valve cover off. Just set this dirty stuff aside, because you're going to want to take that to the machine shop and have them clean all that. Also, you want to take a look at the casting number. So the casting number is right there on the head. These are the last three digits are 810, which is one of the better heads. And then of course all of the gaskets and stuff, you just want to discard that. Now also, what I would recommend you guys, if you're gonna reuse these parts, I would highly recommend that you keep them in order. So just get yourself like a piece of cardboard, punch a hole there like that, and then I'll go ahead and number these once I get them all in there. Your rocker arms here, you don't have to take the rocker arms all the way off. Good practice is to just loosen these bolts up, pull the rocker aside, and pull your push rods out. If you're going to reuse these push rods and these rockers, you want to keep them in order. That's really important because they do have they're wear mated. We are not going to do that on this engine. We're going to put all new rockers and push rods, so we're not concerned about these old parts. Throw them away. We're going to set them aside in case we need to match them up. Now there's a detorque sequence on this intake. You want to start in the middle and work your way to the outside. This bolt here, where this carburetor flange comes out, can be kind of hard to get a socket on. In some cases, it's better just to get a wrench down in here on this and break that loose. We want to detorque these from the center out, alternating back and forth, and go to the outside. Okay guys, so once all your intake bolts out, a lot of times the intakes are stuck to the motor pretty good. So the best place to do this is go right in the back between the block and the intake. Just kind of take a screwdriver and just tap it in there lightly with a soft hammer. You're not going to hurt the intake doing this. So you see we pulled it loose there, and then it's just a matter of pulling it off of there. Then you just pull the intake straight up off of the engine. It comes off there fairly easy. Set that aside. Now we have exposed our lifter valley. Of course, we took the push rods and so forth out of this side. We got to do the same thing over here. Now the small block Chevy has three rows of head bolts. There's a row down here, shorter bolt. There's another row in the middle, and then there's a few up top here. There is 17 head bolts. There's also a detorque sequence for this. So what you want to do is start in the middle with this middle bolt. And you want to start detorquing there, and you want to go in a circular pattern. So you want to go down and you want to go out from the center out in a circular pattern. If you don't really fully grasp that, you can just look up you can Google it on the internet, and they will show you all the torquing and detorquing for these heads. But I'm basically just going in a circle here on all these head bolts. These lower bolts down here are the short ones. That's a short bolt. The upper bolts are long. There are two medium-sized bolts, and I'll show you what I'm talking about, and that's the ones on the end. The one on the end here and the one on the end here. If you look at the length of these bolts, the bolt that's on the end is shorter. So there's only two bolts like this that are medium size, and that's the front and the back. All the upper bolts are long, and all the lower bolts are going to be that shorter. The best way to get this off is to take a long pry bar, kind of show you on this head over here, even though the bolts are still in this one, you just want to put that pry bar on the intake and just kind of pry up this way on it. I'm going to do it on this head here. Now remember, be very careful. These heads are heavy. It's going to come off. Pry up on the head this way. You can see how it's coming off there. There's a couple of dowel pins that locate this head on the block down here in the corners. So once you break it loose, just pull it up on the intake side towards you and make sure you're holding it, because it is going to come off there. So there it is. You look at your head gasket here, see what your tune looked like. This thing's not blown. It looks like it was sealing pretty good. He said this engine was running good. And look at your fire ring all the way around here. Make sure it's not broken anywhere. I don't see any signs of leaking or blown head gaskets or anything. Now the pistons are going to have carbon on them. That's normal. Now if we look at our head here, it's very interesting. The exhaust valve is the smaller valve. If your tune is correct, your intake valve should have a light coating of carbon on it, which these do, and your exhaust valve should be like a crispy brown color, like peanut butter. Well, they're pretty good. I do see something on that far left cylinder though. If you'll notice, that far left cylinder, the exhaust valve is a lot darker than the rest of them. That is usually a sign that there's some oil consumption in that cylinder. You can look at this. Other than that, it looks like this thing was burning pretty good. It had a good air-fuel mixture. One of the things that messes up engines a lot is incorrect air-fuel mixture, either rich or lean, and this one looks like it was pretty good. Now, we're going to do the same thing to the other head. Get down to the short block. There's 4 bolts in the water pump. Of course, you want to pull the water pump off. We're not going to reuse that thing. And then your pulleys up here, that's pretty straightforward as far as getting that off. I do want to show you how to pull the harmonic balancer off. And you just run this in, that is going to pull. The balancers are pressed onto these engines. They're not going to come off by hand, so you have to use a pulling tool. You can do this by hand. I like to use the air gun. And there's your balance. All right, guys, so that is basically your short block. I'm going to get the other head off here. I got to take the bolts out, take the head up. That's it. The only thing you have left is your timing chain cover and your oil pan. That's pretty straightforward. The lifters, if you're going to reuse the cam, these lifters in here, it is imperative that they stay in order. I don't recommend that you reuse a flat tappet cam. They usually wear out. We're going to replace all that stuff. Also, look at the condition of your cylinders. These look like they're glazed pretty good. So you want to see a crosshatch in there. We'll talk more about that later. At this point, once we get the head off, then we start digging into the bottom end. I'm going to switch over to the Vortec motor. If you're trying to buy an early small block engine, a lot of the very early engines from the 70s are pretty clapped out and kind of wasted nowadays.
I want to talk to you about the block that you should be looking for. These are readily available and they are a very good quality block. This engine was only made for about 5 or 6 years. It was made from 1996 all the way up to about 2002 in the trucks, and they had marine engines also. And this is the 5.7 liter Vortec engine. Now, there's some features on this block that are really excellent for building a street rod, and I'm going to talk about those. So the last 3 digits of the casting number on the block that you're looking for is an 880. This is an 880 casting, and there's a couple of things that are pretty obvious about it. One of the things you'll notice is in the back it has a one-piece rear main seal housing. This rear main seal setup, now they actually use this rear main seal setup on the TBI engines too, so it would have been 1986 and up. In 96 they went to the Vortec style motor. Some of the TBI motors are usable or something that you should be looking for, but I'm going to show you there was a couple of differences on the TBI engines. Some of the TBI engines were not machined for the roller cam setup. If you can, what you want to do is try to get the roller cam block. All the Vortecs were roller cam block. The Vortec 880 casting, it's also going to have a windage tray. It has a larger tube. It has a 5/8 tube oil pump. So the oil pump is different. It has a much larger pickup tube. I've already taken the bolts out of this. So the oil pump bolt goes through the windage tray, and then there's 3 main cap bolts that come up, and those are provisions for the windage tray. I got the bolt out of this, so the oil pump comes out, so it's got the bigger updated oil pump. Another thing that's very common on these is the connecting rods. I've already taken a couple of these out. This is a powdered metal connecting rod. It's different than the earlier forged rod. It is a forged rod, believe it or not. A lot of people don't realize that, but this is what they call a powdered metal rod. The way they manufacture these rods is they take metal powder, they grind metal down into very fine iron filings or metal filings, and then they compress it together. They put it in a press in the shape of the rod, and they put a 200,000 pound press head on it, and they press it into the shape of the rod, and then it goes through a multiple stage heat treat process. The powdered metal rods are actually fairly new on the automotive scene. They've only been around since like the early 1980s. Now I know some of you are thinking, God, I wasn't even born in the early 1980s, or a lot of you probably were. But in scope of the automotive industry, the 80s was relatively recent. Ford started out using these in one of their cars. They took a chance on it. Now, powdered metal rods have actually gotten kind of a bad rap. I've heard negative things about them. Mainly, I'm going to go out on a limb and say that's because the people that are saying negative things don't really understand powdered metal rods. Fact of the matter is that these powdered metal rods are 25 to 30% stronger than the earlier Chevy conventionally forged rods. That's been proven. They can take more horsepower. These are very, very good rods for a street motor. So if you get a set with powdered metal rods and they look different, they have a rounded edge, they don't have the balancing pad that's square up here, they're more rounded, and it's just, you can tell it's a different style of rod altogether. Powdered metal rod's a very good rod. Cast piston motor, we're going to throw the pistons away, we're not going to use those. The nice thing about it though is the bell housing bolt pattern, the starter mounting, the oil filter adapter and housing, all of that is the same as the early block. So this is going to bolt right into your early street rod or whatever you're working on. The oil pan is different with the one-piece rear main seal, so you're going to have to get the pan that goes with this. A couple things on the front of the engine. So there's a couple features on the front of the engine that are different. One thing that you'll notice is that there is a machined pad here, and there's a couple of bolt holes. There's actually a camshaft retaining plate that goes here to retain the roller cam. When you do a cam upgrade on the earlier Chevrolet engines like this one here, you'll notice that it doesn't have a machined area and a provision for the roller cam. This is a late 70s block, but it doesn't. This is designed for a flat tappet. So the difference is you have to use a thrust button in this thing if you're going to put a roller cam in it. The 880 block features this machined area for your retaining plate, and so you can run a replacement cam that's a fact type roller cam. The reason you want to do that is because this is already set up for a roller, and factory roller replacement cams, the performance cams that are designed to run in a factory block, are a lot cheaper than the retrofit for the earlier block. So you're going to save a lot of money, and you can still run a performance roller cam in there. So it works out pretty good. Now, I talked earlier about the fact that the throttle body injection blocks, which were 86 and up, it is possible you can use use one of those too. It's a different casting number, but what you need to look for is these holes being drilled and tapped for the plate. Now a lot of the throttle body engines used a similar type block, but they had a flat tappet. The other thing is, in this Vortec block, you can also use a flat tappet cam in it if you want to. You don't have to go roller, I recommend it, but these blocks will take either type of cam. So a lot of the TBI engines had all of the provision for the roller cams, but they didn't run rollers in a lot of them. Some of them did have rollers in some of the performance applications, but a lot of them did not. So you want to look for that boss with those tapped holes. Now the other thing is the front cover. This is a marine engine that we're working on here. You'll notice that there's a couple of dowel pins here on the front. Those dowel pins are to locate the timing chain cover. So this is just your typical small block Chevy timing chain cover. It's the same cover they've used on these things for 50 years. So since this is a marine engine, even though it's a Vortec, they did use, and those pins right there are to locate and center that seal. So they locate the cover. This is the early style cover. Now, the Vortec, a lot of them came with a plastic timing cover that had a sensor in it, reluctor wheel that you'll see on the front of the engine, and it goes right there in front of that gear. And what it was is the plastic cover went on here, and there was a crank position sensor in the cover that actually picked this up, and this, since it's keyed onto the crank, would tell the computer where top dead center was, right? It's basically a crank trick. You don't have to run that. If you're going to run a carburetor or you're going to run some kind of fuel system, you can just take that off and leave it out. Now if you're going to run the Vortec fuel injection and use the sensor down here with the plastic cover, you have to make dang sure that this thing is on here. The engine's not going to start, but you can just take it off for hot rod purposes. You don't even have to put that back on. If you are going to run the front cover, now if you get an engine with a plastic front cover on it, what you'll notice is when you take the cover off, these two dowel pins are not going to be here. There's not going to be anything in these holes because the plastic cover has those dowels built into it, and they just protrude into the block right out of the cover. If you have a plastic cover and you want to update your block, or you want to use an earlier style timing cover, the steel one, all you got to do is get these dowel pins and tap them in. The bolt pattern is exactly the same on the front of the motor. The only difference is the Vortex had no dowel pins. The non-Vortex, or the ones without the plastic cover, you just put the dowels in and boom, you run your cover from 1970 on there. You run your aluminum performance cover or whatever. That's the nice thing about this block, very interchangeable. Now this particular block is a 4-bolt main. Most of the Marine were. Now the crankshaft is different. It's a one-piece rear main seal crank, so it is definitely a different crank. Most of the cranks, in fact all of the cranks that they made in these, were nodular iron. They weren't the early cheapy like 442 casting cast iron cranks that the old Chevys had. This is a nodular iron crank, and it is much, much stronger than the earlier Chevy cast cranks. It is a cast crank, but these can take a lot of punishment. I've seen these take 600-700 horsepower and live for a long time. So these are good crankshafts, even though they're not forged. Now if you're going to do some kind of boost or something, then you probably want to forge. You want to look for these bosses here. Now these are what take the roller cam provision. So the roller lifters go in here, and over each set of lifter bores you have one of these little crow's feet thing, and it sits over the lifters, and what that does is the lifters sit inside this, and it keeps the lifter body from rotating. It holds the roller in line. So you're going to see this in there, and you're also going to see this spider assembly. This has 3 holes in it here, and it bolts up just like that. So you'll see when you pull the intake off, if you see this sheet metal spider assembly in here and one of these over each set of lifters, you have a roller cam block. But even if it's a TBI motor, guys, it's not going to have this assembly in it. It'll have flat tappets just like the early Chevy. But what you want to do, in addition to looking for the machined areas up here for the retaining plate, you want to look at these bosses here and make sure they are drilled and tapped. Because if they are, then that block is set up for a roller cam. So that's what you're looking for if you're looking for a TBI motor and you want to convert it to roller. I actually want to talk to you for a second about these head bolts. Now, I know I told you to keep the push rods in order, but I didn't do that. That's only if you're going to reuse them. I know I'm not reusing these push rods because we're going to go with a roller cam on here. The roller cam lifter is a lot taller and it requires a shorter push rod. So we talked about how we got the block with the provisions for the factory roller, but just keep in mind, if you're going to go with a factory roller, you're going to have to buy a set of push rods to go with it. Now on the head bolts,
This is the earlier style head bolt, which we're fortunate. These head bolts do not have to be kept in order. They're not wear mated, and they are reusable. Chevrolet head bolts, you've probably been told, oh, don't ever use head bolts. Chevrolet factory head bolts, the earlier style, are extremely strong. They're really high grade of bolt, and GM says it's perfectly acceptable to reuse them. Now, here's the rub on that. If you get one of these engines and the head of the bolt takes a 1/2 inch socket, this particular bolt here takes a 5/8 socket. If you get the head bolts that have the head on top that takes a 1/2 inch socket, you cannot reuse those. Those are torque to yield bolts. So that's how you can tell. It depends on the size socket it takes to get the bolt out. If it takes a 5/8 socket, great, reuse them. If the head of the bolt takes a 1/2 inch socket up here instead of a 5/8, do not reuse those bolts because they're torque to yield. They're one-time use only. And they went to that, I'm not sure what year, I think it was late 80s, early 90s, they went to that torque to yield stuff. So
visual on this, we noticed the timing chain was pretty loose. We also had quite a bit of rust in the cylinders. It looks like this thing sat out in the weather. The timing, the lifter valley area here, a lot of rust on the lifters and the lifter hold down and so forth. So we're going to have to spray some penetrating oil and stuff on this to get it apart. And if you look in the cylinders here, you can see there's lots of rust. One of the things that we need to be real sure of on the motor is we don't know for sure that the bottom end doesn't have any severe damage. Here's the casting number for the 350 Chevy, and you can look this up online. If you're not sure when you're looking for an engine what it is, look for this casting number and then look it up online. I'll tell you what it is. The nice thing about this year span of Chevrolet is they actually put the engine size right on the block, 5.7 liter. So this is definitely a 350 engine, which is what we were looking for. So once you get the correct engine, you get it up on the stand, then we start thinking about getting this thing to turn over. Well, we noticed, you can see here that I'm having a real hard time. This engine does not want to budge. It doesn't want to turn in either direction. I put a little penetrating oil on the cylinders. You can see that the cylinders and the pistons are wet. Work this back and forth. Eventually, you can probably get this thing to free up, and you're going to have to get it to turn to get it apart. And you can see this thing starting to move. So that's a good sign. If it starts to move, that's a good sign. Just continue to work with this thing so we can get it to where it needs to be. And eventually, if you work it back and forth hard enough and you got good penetrating oil on there, you should be able to get this thing to rotate, as long as you don't have any catastrophic failures connecting rods that are bent or busted or anything on the bottom. I like to use penetrating oil. The TAL5 works good. This is a WD-40 product. And also it helps if you wipe these cylinders out. You can use some type of a cleaner if you want to. This is just like a high concentrated household cleaner here that I'm spraying in there, and I'm going to wipe these out because I want to get any of the dirt. There's also, in addition to rust, there's a lot of dirt and stuff that got in here. Get that out of there as best we can so we can get this thing to turn over. Just wipe these out really good, wipe any excess dirt off. Just make sure you got plenty of lube on here so that these pistons have at least half a chance of turning. Really good positive sign right there. If you can get this thing to turn over, you probably got a fairly decent core on the bottom end. Now we're going to take our lifter anti-rotator bracket off here. Hang on to these bolts and this parts because you're going to need to clean those up and reuse them. Just set them aside, put them in your cleaning solution or whatever. Then we can start taking these are the crow's feet, they call them, the lifter brackets.
There's a couple of changes that General Motors made with their small block Chevrolets, and I want to talk to you about them. So the earlier engine basically had a flat tappet lifter like this, a push rod, and if you look at these two or these lifters rather, you can see the difference. Flat tappet lifter is about 3/4 of an inch shorter. So GM, because of the extra roller mechanism that they put on the roller lifters, they had to make the lifter body longer. And when you go with a roller cam, the lifters most generally are longer, so you can see there's quite a difference in the length of the lifter. Well, in order to make up for that, what GM did, they just use a shorter push rod with the roller rock arm. Now this is a traditional push rod for a flat tappet lifter here. If you look at the roller push rod, you can see the difference there. The roller push rod is actually about that much shorter, which is basically the difference between the lifters. So what they did is they shortened up the push rod. So if you're running a roller cam or you're going to convert to a roller cam, you have to remember that the roller push rods are shorter, quite a bit shorter. So you have to make sure that you get push rods for a roller cam. The other difference is in the rocker arm. The earlier rocker arms, this is just a typical rocker arm from a 350 Chevy. You'll notice the area that contacts the valve here is just a flat pad or surface, because what we have is a push rod guide that is machined or built right into the cylinder head. So in other words, where the push rod goes through the cylinder head, there's a casting guide, or a cast guide in the head that actually takes, this goes through the cylinder head, and the portion of the head that this goes through is basically a guide. It's a cast iron guide, and it holds the push rod like this so that the rocker arm won't be wobbly. The later ones, the cylinder heads don't have a push rod guide in the cylinder head. They actually have a hole, a round hole. So where the push rod goes through the cylinder head, instead of having a push rod guide here that kind of holds this push rod in place, they've just drilled a round hole like this so that this push rod it'll flop around. There's nothing to keep the rocker arm from doing this on the head, except for this. The later rocker arms, they have a slot on the rocker. So because there's no push rod guide plate or guide per se built into the cylinder head, what they did is they put a rocker arm that's slotted. So on the later model roller cam engines, you're going to have to use a set of rockers that were basically 1986 and up. They have a slot cut into the rocker, and you can see the difference here. This is the early rocker with no slot, and then we have the later one that has the slot. Other than that, the rockers are very pretty much the same. They're identical. The only difference is that slot. If you were to ever put this early rocker on there with no push rod guide, this rocker it would come off of the valve. It'd be going sideways, and that's no good. So you got to make sure you get the right rockers. The fulcrums that go inside, that's this little half moon shaped guy right here. This is the fulcrum. It drops down into the guide like that, and they're all pretty much the same. Late model, early model, those fulcrums are the same. The other thing is the rocker nuts should always be replaced. These rocker nuts are, if you look at the top, you can kind of see that they're crimped at the top. There's a crimp up there. That's because this is a self-locking nut. And what keeps this nut from backing off and causing you to lose your valve adjustment is the fact that it has a crimp up on top. When you run this down onto the rocker stud, when you get to the top up here, you'll feel this thing get tight. The reason it's tight is because it's crimped, and that makes it a self-locking nut. Now, the reason you should replace these is because you can only run these down a couple of times before this nut loses its ability to self-lock, and what happens is they get loose up here and start the engine because of the harmonics and the vibration of the engine. What happens is those old nuts, they start backing off and you lose your valve adjustment. It's a good idea. They're not that expensive. You can buy 16 brand new rocker nuts for probably 12 bucks or something. Go ahead and put, every time you build one of these or anytime you change rocker arms, go ahead and buy yourself a new set of rocker nuts. That's pretty important.
Get these off there, and again, save these too, because you're going to need these. You're definitely going to need these to clean them up. Our lifters were kind of stuck in this block. We definitely had rust on these lifters. We will for sure not be reusing these parts. On a rebuild, you normally replace the lifters and cam anyway. If you do happen to be in a situation we're going to reuse these, make sure you keep them in order. Pretty important. So once you get the lifters out, then we can start looking at the rest of the motor. We want to get the timing chain off here. I got the motor upside down right now. I just rotated it around. Take the 3 bolts out of the timing chain gear, and you want to save these bolts because you're going to reuse those back. We're going to replace the timing chain and gears, of course, but the bolts are going to be reused. So we want to put those with our bolt collection. Then you just kind of work this chain back and forth off of here, and these usually come off pretty easy. You may have to get some screwdrivers or something to pry it off. This one came off easy. And again, we're not reusing that. So once you get to that point, it exposes the front of your cam. There is a cam plate on this. This is a cam retaining plate specifically used on the roller cams, and we'll get to that later. The oil pan rail on this particular engine had lots of grime and crud on it. One of the things that I would recommend you do is get a little box or a garbage can or a bag or something and scrape as much of this crud off here as you can. Because if you put your tool on here, this grime and grease and sludge that's on here is going to end up being slung all over the place. It's going to end up on the floor, and you're going to be tracking it all over the place. So we want to kind of clean that off as good as we can. Also, if you have a shop vac, it really helps. We had a lot of crap on the top of the motor here. We actually had some rats that had made a nest up here. There's lots of rat turds and things. Any of this excess stuff, to keep it from going on the floor, it's a good idea to just vacuum all this off of here. And it really helps keep your area clean when you're disassembling this. Otherwise, you end up just walking around through a big mess. So just kind of try to be as neat as you can. Then we start taking our pan bolts out. I like to use a speed handle for this. The pan bolts on this later Chevy block are 3/8, so a 3/8 socket. Again, save the pan bolts, don't discard them. Once you get the pan bolts off of this thing, it's probably a good idea to, the pan may be stuck on, so we want to take a soft hammer and smack the pan really good. There's a couple of pan rails also on here. Make sure you save these. Don't throw these out. These are going to have to go back on after they're cleaned up with the new gasket and so forth. Those are what help the gasket to seal. There's one of these on both sides. Make sure you get both of them off and set them aside and clean them up. Then we take our pan off, make a visual inspection of the inside of this pan. We got some grime and crud and some carbon buildup on here, but it doesn't look too bad. It doesn't look like there's any catastrophic failure going on here. Set the pan aside. We're gonna be needing that later. We'll clean that up at the machine shop, at the block shop. Take a good look at your oil pump pickup screen here. On this one, we had quite a bit of sludge and crud in here, and that's not that unusual for a motor with a lot of miles on it. But we definitely are not going to be reusing this oil pump pickup tube. You can see all the crud and slime buildup. There's a 5/8 bolt that holds the oil pump on. Go ahead and take that out. Pull your oil pump off. Save the bolt that goes in there. That bolt is a unique bolt, and you're going to need to reuse that for your pump. There's also an oil pump drive shaft that goes in here. You want to pull that out. There may be a plastic retainer on the end of it. Just kind of take that off and discard it. Hang on to this drive shaft, though, because you'll probably be reusing it. Now we can take a look at our lower end. We can start looking at our connecting rods. Now this is a 2-bolt main block, obviously. That means that the main caps have 2 bolts rather than 4. But that's fine for the street. This is not going to be a race motor or anything. So for mild street performance or stock application, 2-bolt mains are perfectly fine. You also want to look at your rods. I like to check the rod side clearance. Make sure that the connecting rods have movement in them. Make sure the engine rotates without any binding. And if you move these rods back and forth, they should have a little bit of side play on the rods back and forth, and that's a good sign. If they move and they're not burnt black or purple, that's a good thing. Then what we want to do is we want to take our rod caps off. Your rod caps, there's a couple of nuts on here, so break them loose. Take one off, take the other one about 3/4 of the way off, and then smack it with a hammer. That will break that rod loose. Then you can take the nut off, and now that the cap's loose, you can work that cap off there. Just work the cap off, and then you can start looking at your bearings. The bearings in this engine looked really good. They showed some wear, but they weren't wiped out or hammered. Once you get that done,
you got to be really careful when you take this out, because these are hardened studs here. You don't want to just push this out. This is what you need. This is a tool called a journal protector. Now I bought this at Summit. Just look up journal protector. They only cost about $14, but it's money well spent. Order one of these. These go right over the studs, and now it also gives you a handle to drive that piston and rod out. So you just very, very gently drive that piston and rod out like so, and then we come around to the other side and we just take our piston and rod assembly. There's going to be an upper bearing in here. You want to take that out as well. Now we're not going to reuse these pistons, obviously, but you want to set this aside. One of the things that you really want to make sure you pay attention to is once you get one of these off, take the cap and put it back on that rod. You cannot mix these caps up. If you mix these caps up, especially if they're not numbered, you're going to be in trouble. Now, here's something to keep in mind. There's a couple of bearing notches here. There's a bearing notch right there. You see the notch? And then there's also a bearing notch right there. They're not going to line up with each other, right? This notch here is going to be over here, but those two notches, you see we've got the notches on the upper side there. There's a notch right there, and there's a notch right there. Those two notches, when you put these together, they go to the same side of the rod. So they're going to be on the same side. If you look in there, you can see them. There's a notch there, and there's a notch there. So they're on the same side. If you got the cap notch over here and the rod notch here, you got the cap on backwards. If you put the motor together with the cap on backwards, you're going to blow your engine. So these caps are definitely directional. They got to go on the same place, and they are married or specific to their rod. You don't want to ever mix them up with another rod. So we're going to take the caps one at a time. Before we even crack the nuts loose on the other rod or the next rod, we're going to take and put this cap on, and we're going to put the nuts on just hand tight, and then we're going to set this aside. That way it stays together. Alright, so now we've got our rods and pistons out. The nice thing about this engine here is the crank's turning real nice, and also the rod bearings all look pretty good. You want to look at your rod bearings and make sure they're not wiped out. Our rod bearings were showing some wear on them, but it looks like normal wear and tear. There's no copper showing or anything like that. If you got copper showing, it could be a problem. So another important thing here, if your caps are not numbered, you need to make sure you number them with a metal marker or a stamp or something. The nice thing about this engine, this is a marine engine, and a lot of the marine engines, Mercury Marine and some of these other places, get a hold of the factory Fortec blocks and they redo them with marine parts, so they usually number the caps. So these caps are numbered. They're 1, 2, 3, 4, and then the number 5 cap is unique. So they're all numbered back here. So the next step is to get your bolts out and get your caps off. You can use a breaker bar for this or an impact. Just run all these bolts out. Now the easiest way to get these caps off is just take your bolt and pull it out almost all the way and just tap it to the side like that, and that cap will come off. And you can see that's our bearing there, and the bearings, again, not showing any copper or anything, normal wear and tear. So this crank and these bearings look pretty good. And you want to just get all of them off, and that'll expose your crank. Now once all the main caps are off, there is one other step you got to take on the one-piece rear main seal block. You can get all the caps off first. Alright you guys, so on your seal housing, there's 3 bolts that take a 3/8 socket, and there's 1 nut and stud that takes a 7/16. Now you got 1 long bolt here, and then these 2 down here are going to be shorter. Now these are special bolts. This is a special link bolt, so you want to make sure you save that. It's different, it's a little longer, it's not like the pan or anything else. These bolts are unique to this cover, and you want to hang on to these. And then we're going to need a 7/16 for that nut. Take the nut off. Those are the 4 pieces. And then it's just a matter of working the rear seal housing off. There's your rear seal housing, and yeah, it's pretty straightforward.
Okay, so here's the dealio. There are basically 2 different rear main seal setups on the small block Chevy. There's an early setup, which is a 2-piece rear main seal, and then there's the later one, which started in, I believe, 1986, and they went to a 1-piece rear main seal, which, by the way, is much better. So, but a lot of people get confused as to, you know, what they can do with these blocks, what's the interchangeability of them, and so forth. So I kind of want to talk about that. So first of all, let's talk about the early small block Chevy. Everything from 1955 all the way up to 85. And let's look at one of those crankshafts. Okay, so this is your early 350 Chevrolet crankshaft, and this is the cap that goes on it. It has a rear main seal that's just this lip type seal. It's a 2-piece seal, and the way that this works is the lip seal fits on this groove. It fits right there in that groove, and it's important when you put this on that the lip portion of this lip here faces the oil. And basically this cap goes on like that. It goes over the crankshaft just like so. And our lip seal surface is here, and the lips and also this lip here is going to go in the block, and it rides here just like that in the block. So that's your 2-piece rear main seal. Some of the other differences are the bolt pattern on the back of the crankshaft is different on the 2-piece rear main seal than it is on the 1-piece, which is what we have here. So it's the 1985 or 6 and up rear main seal, which is a one-piece seal, and it actually has an aluminum housing that bolts to the back of the block. This is going to bolt onto the back of the block, and there's a gasket that goes here between the block and this housing. And if you look at the back of our marine engine here, this is a one-piece rear main seal. It has a dowel pin there. That guy just goes on there basically just like that. You can see the flanges on the early and the late are totally different. The seal basically goes over that surface there, and this round one-piece seal rides in there now. So they are very different. Also, the bolt pattern here is not the same, so it takes a different flex plate. Now here's the thing, and obviously if you look at the caps next to each other, you can see, geez, they're totally different. The caps from this point here up are pretty much exactly the same. They take the same oil pump, they take the same oil pump drive. The only difference is they don't have this extra piece for the rear main seal. They have this one piece setup that bolts onto the back. And of course the cranks are different. Now, the nice thing about these engines is pretty much anything you can do with this early crankshaft and block you can do with this one. So the differences are the caps are different, the seals are different, the flex plate bolt pattern is different, so it takes a different flex plate, but that is about the gist of the difference. Everything that I can do with this motor as far as cam, heads, pistons, rods, whatever, is basically the same as this one. It takes the same main bearings, it takes the same rod bearings, you can use the same set of rods, you can use the same set of pistons. The bores on the block are the same. The timing chain covers on the front of the blocks are the same, at least until you get up to the Vortex. You can put the early heads on these blocks. You can put the early 4-barrel intakes on them. So really, the only differences is in the way that the rear main seal mates, the way that the block is designed differently, of course. But if you want to run one of these later model one-piece rear main seal blocks and put all your early stuff in the block and on the block, it works. Everything is pretty much 100% interchangeable on these things. So that's kind of the difference between the one-piece and the two-piece rear main seal. At that point now, we can just grab onto the crank in the back and the front, and you want to pull it straight up out of there and just set it aside. You also want to remove your upper bearings here, inspect them, make sure there's no copper showing. These all look pretty good. Now the rear bearing is the thrust bearing. It's going to be a little different. It's wider and it has flanges on it. Just take a hammer and tap it on the opposite side from the bearing notch and it comes out. That's your thrust bearing. Now that you got the bearings out, we want to get this block ready to go to the machine shop. And hang on to these bearings. Don't throw them away because you're going to need to. You might need them later to reference sizes and so forth. So now that we've got the block to this point, we also want to pull all the plugs and everything and strip it and get it ready to go to the machine shop.
Now let's turn our attention back to the camshaft. There's a couple of retaining bolts that hold this plate on, so we need to loosen those up. And again, these are special bolts, these retaining bolts. You want to keep these separate. Also, the retaining plates, you're going to be reusing that, so put these in a safe place so they don't get lost. At that point, then we can take a screwdriver or something inside the block, and you can just kind of nudge this crank out of there, this cam out of there rather. It should come right out. The cam, you want to turn it slowly and pull it out, and it should come out fairly easily. You don't ever want to force it out. Something could be blocking it. In this case, we do have something blocking this cam, and it looks like it is on this block, we have a fuel pump, mechanical fuel pump set up, so there's a plate here on the side of the block and a couple of retaining bolts. Just take your 3/8 and a speed handle or whatever and zap these bolts off of here, and this retaining plate will usually be stuck to the block, so you may have to smack it with a hammer to get it off. But get the bolts out, give that plate a big smack, and there's a shaft in here that actually actuates or operates the mechanical fuel pump. That shaft will stop the cam from coming out of the block, which is what is happening to us. So there's your plate, set that aside, and then you can tilt the block over. It may make it easier. You can try to push it up from the inside and grab onto it, and we can just pull this thing right out of here. And that is your fuel pump drive shaft. It goes in and sits up against a special lobe on the cam called a fuel pump eccentric. It's right on the front here, and as the cam rotates, this shaft is pushed up and down, and it actuates the arm of the mechanical fuel pump. So you want to hang on to that because we don't know if we're going to be using that or not. We may use an electric pump, who knows. The cam should be free to come out, just very gently pull and twist at the same time and get that cam out of the block. Once we get the cam out, we want to do a visual inspection on it. This cam looked like it had seen better days. It is a roller cam, so they don't wear too bad, but this one had some rust pits and some wear on it. Once we started looking at it, the gear on the back also, the distributor gear showed a little bit of wear back here. We'll probably end up replacing this camshaft, but so we'll set that aside for now.
Now, as far as the plugs go, there's a couple of different ways to get these out. What you want to do is take a chisel or a punch and just knock the plug down inside. Now, you don't want to leave it in there. You don't want to lose it down in there because this will create a hot spot in the block. So you want to get that out. So once I get it to that point, you can either take a set of vice grips. On some of these, we'll probably use vice grips. Just take your tool. You got to kind of finagle this plug and just kind of pry it up out of there. And there's your core plug. You want to make sure you remove all of them. And those, we're not going to reuse them, so you just discard them. Now, I want to talk to you off camera. I'll get the rest of those out. I also want to talk to you about a couple other things that you need to be concerned with here. All right, now, so on the back of the engine here, there is a cam plug that has to come out when we get the cam bearings out. There's also a couple of core plugs here, and we'll finish getting those out. But on these plugs here, there's 3 oil gallery plugs. There is an oil passage that runs all the way down the length of the block. These 2 here run through the lifter bores, and this is the main oil gallery. These plugs all have to come out of here. Now these have take a special tool that has a square head on it from the factory. The replacement plugs will be an Allen head. You don't necessarily have to get these out if you don't feel comfortable doing it. But one thing you need to make sure you do is when you take this to the machine shop, make sure that the machine shop takes those plugs out before they put it in their acid tank. Because if you don't, there's going to be sludge built up behind those. So all of the gallery plugs need to come out. There's 3 back here. There's 3 more in the front of the block at the other end that have to come out as well. Most of you are just going to let the machine shop take those out. That's kind of a machine shop deal. But the main thing is just make sure that they strip all the oil gallery plugs out of the block. So we're going to take our tool, and again, the machine shop can do this, but I've got the square tool in here that's designed for that square hole. You just knock it in there, and then you're just going to take these gallery plugs out. Want to make sure you get these out. Because what will happen is sludge will build up in that gallery behind there. So once you get your oil galleries out of the back, there is also plugs at the other end. This is up in the front of the block. Now these plugs are not threaded. They're just a little miniature version of the freeze plug or the core plug. And it's actually kind of hard to get these out this way, so the best way is to drive them out from the back side. What you can do is you take 3 old push rods. Make sure that these are push rods you're not going to use in an engine. And you just put them in the gallery hole, and they're going to run down the length of that. If you get 3 of them in there, it's just the stock type Chevy push rods, you can see the last one is sticking out this way. And now I can tap on this. It's going to push that plug out the front. I just start tapping on this thing, and you can see what's going to happen up here. There it goes. You might have to tilt the block to get that 3rd push rod to slide out, but you just do that for all 3 of these holes, and that'll push this front plug out, and that'll open up your oil galleries. And you can see this is one of the push rods that we use in an oil gallery. And you see all the sludge and crud that's inside that oil gallery. That's why you got to make sure you get those plugs out. So when they take this to the machine shop and it's submerged in the chemical can get in and eat all the grease and sludge out of the galleries. That's really critical on these engines. One of the worst things you can do is have this engine clean but leave those plugs in. Externally the block will look clean, but you've got sludge and crud behind the plugs, and then when you assemble your motor, all that sludge gets washed right down into your new bearings, and that is bad business right there. So inside the block there's also a cam bearing. You see this bearing here. There is a cam bearing that is pressed into this block. Now most of you are just going to go ahead and let the machine shop take that out. I'll demonstrate that because I want to show you something that's behind that
cam bearing and why it's so important that these are removed before the cleaning process. This is a cam bearing driver. It's a tool that most of you are not going to have. This is what we use to install and remove these. It has an expandable end on it. It goes inside that bearing, and this rubber piece expands in there. And then there's a lip out here that's going to catch that. And again, the machine shop will take these out, but make sure that they get these out. So we're going to put our tool in here and just expand it out inside that bearing, just till it's snug. And then we use this like a driver to just push that bearing out. So there's your cam bearing. That's the bearing that was in that bore. And that exposes the cam bearing bore down here. I'll show you why it's real important to have the shop take these out. So if we look at this cam bearing bore here, there's actually a groove that goes around behind that bearing once it's pressed out, and there's an oil feed hole. You can see that. If you clean the block with the cam bearings in, any of the sludge that's in here can actually get trapped in this groove here and stick in here behind those cam bearings during the cleaning process. Again, it's trapped in there until you start the engine. Once oil pressure flows through here, oil pressure flows all the way around this groove and finds the feed hole in the bearing. Once the oil pressure hits this area after you start your engine, any sludge or crud that's in here is going to go down on your new bearings, and you're going to have a big problem. These little things here are why a lot of new engines don't survive. It's mainly because they're not cleaned good enough. Also, on the back of the one-piece rear main seal block, we got our oil gallery plugs, our cam bearings out. We're going to get these plugs out. There's a stud that goes in here, and then there's a locating dowel for the rear main seal housing. You want to make sure you get those out. Now this stud actually takes a female Torx head on the end, so you can actually take your vice grips and just grab on that part of it. These usually aren't in too tight. Don't grab the threads because you'll damage them. And then you just, this one came right out. And you just take that stud out. And remember, save this stud along with the other rear main seal bolts that we took out earlier, because this is a special bolt. These got to go back in once you get the new seal in. Now as far as the dowel pin goes, it has a slot in it. It expands and it kind of presses in there. If you take your vice grips, right, you can find the slot's right there, and you just kind of squeeze this. You don't got to get real crazy with it. You just want to squeeze it just a little bit, and that will compress it enough to where you can just kind of work it out of there. You want to take this out because during the vatting process, the vat is hot, and it can actually cause, the heat can cause this to expand, and this will fall out and you'll lose it. So you want to save that dowel pin, and then of course the bolts for that. Set those aside with your other bolts for your housing.
Heat them too much because it is a cast iron block, but if you just take and you heat this plug for about 45 seconds to a minute, it's enough just to heat it up to where it comes out fairly easily. Then the factory plugs have a square hole that takes the end of a 1/4-inch ratchet, just fits right in there. Get yourself a wrench for leverage, and once these are heated, they usually come out fairly easily. If they don't come out, you may have to have the machine shop drill them out, but that's a last resort. As you can see here, this block's been sitting around for a lot of years, and once I heated it, plug just comes right out of there. So it's a fairly easy process. Once you get that plug out, you want to repeat it for the other plugs.
So now that you've got the block stripped of all of the core plugs, freeze plugs, whatever you want to call them, the oil gallery plugs, the cam bearings, all of the things that are going to block up those passages, we've removed all of those from the block. Here's what you want to do. You want to take your block, and put your caps back on the block, and make sure that they're numbered. These were already numbered, so we didn't have to do it. But put the cap with the arrows facing forward in their correct location. That's important. You want to keep the caps with the block. You also want to send your piston and rod assemblies with the engine. The machine shop is going to press the old pins out in the pistons, and they can press the new ones on for you too once they determine that the block is good good and you get your kit. They're also going to look at the big end of the rod and they're going to torque this up and measure that bore and make sure it's round. If it's not, they will resize this for you. But before they do that, they're also going to clean the connecting rods and they're going to magnaflux them to make sure they're not cracked. So you want to get everything cleaned and magnafluxed, and that includes the crankshaft, the connecting rods, and the block. Cleaning first, and then they're going to check it all for cracks. Once it's checked for crack, then they can start measuring the cylinder bores, measuring the rod bores, measure the crankshaft, and they can tell you what machining needs to be done. More than likely, they're going to bore the cylinders oversized, they're going to resize the rods with new bolts in here, and they're going to regrind the crank undersized. So those are all machine shop operations, but when you take it in, you at least want to know, you want them to know that you kind of know what you're talking about. So you want everything cleaned and magnafluxed, and then you want an estimate on what machine work it needs so that it can go back together correctly and be a good motor for you. So I'm going to load this up in the truck, take it over to the other shop, and we're going to get everything cleaned up. A word of advice on cleaning: don't take this stuff to the car wash and try to clean it. You're not really going to get it clean because of all the oil passages and so forth. It needs to be submerged in chemical, and I mean, it doesn't cost that much to get this cleaned. It's actually relatively inexpensive. So, you know, why waste your time? I see guys take it to the car wash and they're using the wand and everything on it. That's just a complete waste of time. Take it to a shop and have it done right. Okay, folks, so the next step is we're going to take all of our parts to the machine shop. Now, I did take some video of this when we got our components back after they were cleaned. Unfortunately, I accidentally deleted all of that video, so I went back, and the next portion of video you're going to see is not a 350 Chevy. This is what I was talking about in the beginning. It is actually a small block Ford. It's a different engine, but the vatting process and the cleaning process is exactly the same. These parts were dirty and nasty and greasy, just like our Chevy parts were. And I just want to give you a shot what you should expect when you get the parts back from the machine shop after everything has been cleaned. So I'm going to do a short clip of some Ford parts that we cleaned just like we cleaned the Chevy parts. And then of course we'll move on to preparation of the 350. So here we go.
We took our 289 down to the other shop and we stuck everything in the vat. A vat, for those of you who don't know, is just a big acid tank that basically degreases, eats all the grease and the slime and the crud off of the components. So we went ahead, we also took our pistons off of our connecting rods. We pressed those off of there. And of course we threw the old pistons away because we don't want to reuse those. Our cylinder heads also went through the vatting process. They have not been disassembled yet. I like to disassemble them after the vatting process, and they look pretty clean. Our cylinder block has also been vatted. It's gone through the vatting process, and I also went ahead, we have our sheet metal here as well. We vatted our oil pan and our valve covers. See, the inside of these are very clean. This is what it needs to look like. You don't ever want to put dirty components back on an engine. We also have our intake manifold that went through the vatting process. So we've got all of our major components here that we had go through the vatting process and some machining. And you need to get this stuff to a machine shop and you need to have them clean this. You actually need vat chemical to clean this stuff. There are some other cleaning processes that use an oven and a blasting machine. And those are available too, but again, that's equipment that the average person is not going to have, so you need to take it to a shop and have that done.
Today we're going to wash the block. One of the things that we have to do is we have to final wash this block before it goes together, and we need to use hot water and soap. It's very important. So we got a few tools here that we're going to use. This is an oil galley brush. We actually have two of them, two different sizes. This is a lifter bore brush. And of course we have a cylinder brush. Now, most importantly here, we have our big bucket of hot water and soap. I like to use Dawn with lemon in it because citric acid is really good at cleaning the grit and so forth off the block. Got to do every one of them. Now we have our oil galley brush block. You need to go all the way through. The plugs are out in the front and back. You need to really scrub these good. We need to repeat this time
Time after
multiple
time.
times for these things. Make sure you flush these oil galleys out. Lots of water. We're going to take it over and blow it dry. WD-40 here. Now, for those of you who aren't aware of it, WD-40 stands for Water Displacing Formula number 40. The reason it's called formula number 40 is because it took the guy that invented it 40 tries to get the formula right. The stuff literally displaces water off of metal. So it's okay, even if you have a little water left, to go ahead and spray this thing down. That way you're going to assure that it's not going to rust. Make sure that you do your final wash.
One of the things I want to talk about is the type of pin that you may or may not have with your connecting rod. Now, as you can see, I've got some C-clips that I just took out of the package here. Now, this is the first type of connecting rod I want to talk about. You can see that the type of piston pin that these have is what they call a full floating pin. Now, we know, just like pretty much any other piston, these pins are going to float through the bores in the piston. But the other thing about these is that the full floating pins, and keep in mind, not all engines are full floating. Now, what we did to these connecting rods, first of all, if you're going to reuse connecting rods, which we are here, we went ahead and we pulled the old studs out, and we did what we call resizing the rod. That consists of, we shaved a little bit of material off the mating surface of the cap and a little bit of material off the mating surface of the rod. And then, once we got that done, we pressed our new ARP rod studs in, put the new ARP bolts in, used the correct ARP lube on them, and then we torqued them, and because we shaved the caps there, it made the bore smaller, and then we just honed these out on our rod hone. But the other thing is, and that's pretty standard for any connecting rod that you're going to reuse, you don't want to use the bolt, reuse the bolts, and you want to resize this and make sure the big end's round. Connecting rods are very susceptible to be coming out of round because of all the stress. The full floater is different when we get to the small end. If you'll notice, there is a bronze bushing, and we press the old bronze bushings out and we press new ones in, and these also have to be honed and fit to the pin. So we press the bushing in and we set it up on our hone, and we hone out. It's a very close tolerance fit here on this pin, but you can see the pin slides through there. Okay, so this is also a full floating pin. It's a really snug fit. I'm putting it in there with no lube whatsoever on it. Once you put a little lube on there, it frees up a little bit. But these are freshly honed bushings. It's called rebushing the rod. It's a full floater. The pin floats in the rod, and it also floats in the piston. So you can literally take the full floater, and of course you want to make sure that your rod is the correct orientation here. You can literally take, you want to put a little bit of oil on these when you actually final assemble them. You just slide your pin in there, and then you slide your pin right on through. You can see I slid that all the way through. And so the pin literally is floating in the rod and it's floating in the piston. And then there's a C-clip that goes in there. You take your snap ring pliers and you put your C-clip in there, and there's a groove, and it has a C-clip that goes on both sides. I'm not going to do that to this yet because this isn't ready to be final assembled. But that's basically the full floating piston. So if you hear the term full floater, that's what they're talking about. This is actually much better for performance. Most of the aftermarket performance rods you buy are going to be full floating bushings.
Okay guys, so we talked earlier about how the fact that these are semi-floaters, what that means is the pin is actually larger than that pin bore. If you try to push that in there, you can't. Now when we get them apart, you saw we pressed them earlier, but you can't press these in. So what we do is we use a machine called a rod heater, and you can see that we have coils in there, and those coils get hot and they heat the rod up. Now there's a thermostat on this. You don't want to overheat the rod. You want to get it to the right temperature. We heat these to about 320 degrees, and the thermostat keeps the temperature even, because if you overheat the rod, like with a torch or something, you're gonna ruin it. You could actually cause the metal to fatigue and break in the motor, and that is no bueno. So we've got a piston stop here. We've got this set up, and what we do is we put the piston up here, and we set the stop up so that when we push that pin in, we go all the way up against the stop and it centers it. Now remember, the pistons and the rods are directional. The notch or the dot or the arrow on the piston goes to the front of the engine. So we've set this up so that when we heat this rod up, it'll be the correct orientation. 4 rods go on one way and the other bank is going to go the other way. So we It's probably best that you let a machine shop or some professionals do this, because it is very possible you could screw this up if you don't do it right. Okay, so now we put our connecting rod in there and we make sure it's the right orientation, and then we let it heat up, and it's going to temporarily swell that rod, and once it's hot enough, then we just slide the pin in. Now, I don't really know how to explain to you how I know when that's hot enough. I can literally tell by feeling the rod just from experience how warm it gets here when it's ready, and it is really cold right here now, so it's not ready yet. Now, these pistons actually have the provision for a C-clip in here, and you can use a full floater. That means there's a bushing in the small end of the rod, and it comes with these clips here, and if you have a bronze bushing or a full floater, you have a C-clip that goes in the end of the piston here in that groove right there, and it holds the pin in. But since we're using semi-floaters for budget constraints, we're not going to be using the bushed rods with the C-clips. Alright, so yes, definitely hot enough now. And now we just take our connecting rod and we simply slide the pin in against the stop, and you see how that just slid in there? Now this will be tight until the heat transfers. Right now the rod won't move, and there it goes, it loosened up. And that is your semi-floating connecting rod, and that's how you do it. So if you remember, we final washed the block. Since then, done a couple of things. I had the cam bearings put in, all of the freeze plugs or core plugs, and the oil gallery plugs, and now we're ready to install this camshaft. I like to put the cam in first. Some guys will build the short block first and then put the cam in. I like to put the cam in first because we have access to it here. It's a lot easier to get to. When you're installing this thing, make sure you get some lube on that gear and some good lube on the journals. We've lubed up all of these journals. You don't really have to lube up on a roller cam the lobes at this point. We'll do that when we put the lifters in, and we're also going to soak those lifters, but just be real careful when you go in here. I mean, you don't want to nick or damage any of those bearings. You don't ever want to force this in. If you ever go to put a camshaft in and it's binding or something and it gets tight, that's a problem. You're probably going to have to take it back to the machine shop and have them try to figure out, what's going on. This one seems really smooth. We don't really have any issues. And also, once you get it in, it should turn by hand. You should be able to grab that pin, and you should be able to turn that cam no problem by hand. This one feels really good. So if you can turn it now, if you get it in there and it seems like it's binding or something, again, that's a problem. We can't, this thing has to be able to freely turn, and this one feels really good. We want to take our retaining plate and our fasteners and put them on. Now keep in mind, I haven't put these, remember I told you there was like some small little miniature type press-in plugs that go up here? I haven't put those in yet, and the reason I haven't is because I don't have them here. Now you can go ahead and put your plate on, and it's not really going to interfere with installing these plugs. The one thing you got to make sure you do though, guys, is before you put your gear on here with your timing chain and so forth, you got to make dang sure you put those plugs in, otherwise your engine won't have oil pressure. I like to go ahead and put this plate on here mainly because it just helps keep the cam secure in the motor, and I don't have to worry about it. And this is a Torx head, so I'm going to run these up. I'm not going to torque those at this point because I always go over everything and torque everything before I button everything up. So I'm just using those at this point to hold the cam to keep it from, flopping out of there while we jostle this thing around and do the bottom end rebuild. Okay, so now that we've got that taken care of, we want to take a look at, we final washed the block like I said. The next step is to install the crankshaft. Hey guys, today we got a crankshaft that we just got back from the grinder. It's just been reground at the grinding shop. So they reground this 10 under, that's what these red marks are. So this crank is what we call 10-10. 10 thousandths under on the mains and 10 thousandths under on the rods. The thing that I want to talk to you about today is final cleaning this crankshaft. When you get this crankshaft back from the grinding shop, it is not ready to put into the motor. One of the things we have to do is we have to take a rifle brush and make sure that we clean these oil holes really good. I like to take some solvent, and I will use some solvent on this and get in here and just scrub these oil holes really good, because there's always going to be some residual crud left over in here, especially from the grinding process. There could be grinding material in there. There could be some dirt left in there, even from the batting process. As I do this, there's kind of some dirt and some black crud that's coming out of there on each one of these. We got to make sure we get rid of all that, and we got to make sure these oil holes are absolutely clean. You can probably see that right there. So you want to just really scrub these holes, and take some extra time and scrub these holes. A crankshaft or any engine component for that matter cannot be too clean, but it can be too dirty. So if you over clean it, then everything's going to be fine. But if you under clean it, you're going to have problems. Final wash all of these oil holes, every single one of them, because these are oil passages and we have to make sure that they are totally clean. After the machine shop grinds the crankshaft, they're going to deburr this oil hole here. Hopefully. They're going to do a good job of it. We have to make sure that those oil holes are deburred well. I like to take just a bearing, an extra bearing that I have, and I will take a rod bearing and I will run it over every single oil hole like this. And I want to make sure that that is not gouging this bearing, putting a gouge in it. If it is, then what you have is you have a burr on that oil hole, and you're going to have to get in there with a file and fix that somehow. If you skip doing this, if you skip checking those oil holes for any kind of a burr, and you put the motor together, it could take out a bearing and wipe out your motor. After we get all the oil holes absolutely clean, we're going to final wash this thing with hot water and soap. And again, I like to take the rifle brush during that process and rifle it out with hot water and soap, make sure they're all clean. Clean the crank thoroughly, blow it off with compressed air, and then go ahead and do the bearing thing for your oil holes. Make sure you have no burrs. And then one more thing before you install the crankshaft is make sure that you mic the journals. Check the journal size after it's been ground compared to manufacturer specifications, minus whatever they've taken off, of course, and check your oil clearances. Don't take for granted that they ground every one of these exactly right, because machine shops do make mistakes. Crank grinders can make mistakes. If there is a problem, you're going to need to take it back to them and say, hey, we got a problem here, and they'll take care of it. If you install it in the motor, it's yours. They're not really going to fix it if you don't take the time to mic these journals and verify that they are correct. It's actually not acceptable at all to get a crankshaft back from a machine shop after it's been reground and just put it in the motor. There's some cleaning, some checks you got to do, size checking, oil hole deburr, and all that stuff. It's critical. If you don't do that, you could lose your motor. Okay, so we've chosen Cleveite bearings, which is a really good bearing, and of course our crank is standard, so if you look at the part number, there's no size after it. It's just 909P. If it was 10 under, it would say 909, 10, negative 10 or negative 20 or whatever. We just want to take our bearings. We're going to have a lower set which doesn't have a hole in it. We're going to have an upper set of bearings, which those bearings all have a groove and a hole in it. So those are going to go into the block. So we want to take our bearings and carefully install them into the block. Now you notice I'm wearing gloves here. We want to be sure that we don't touch the surface of this bearing. What happens if you touch the surface of this bearing with your fingerprint is the acid that's in your fingers and your hands will leave a spot on here that will repel motor oil or assembly lube. So in other words, the motor oil will not stick to that portion of the bearing. I've actually seen engines come apart and I literally seen a worn out portion of the bearing here, and you could see the guy's fingerprint actually in that worn out portion where he actually touched it. So it's pretty critical that we don't do that. So the engine's been final washed, but go ahead and take and wipe these bearing surfaces out. I will usually take some type of cleaner. WD-40 works. This is WD-40 in here. Spray a little bit on these areas because dust or something may have settled. We had this engine covered up. This has to be really clean. We want to make sure that we don't have any kind of even dust or anything here. So we want to take and we want to use a lint-free cloth, and we want to just wipe out these journals really well before we actually lay our bearings in there. You don't want to take a chance of having any kind of dirt or grit in this engine, because that is death Death to an engine. Dirt and grit is an engine's #1 enemy. I spent about 45 minutes washing this thing with soap and water. So we want to make really sure that this is super clean. It's almost like a surgical operation. Then we just take our bearings. It doesn't matter where you put them, what order they're in, because they're new. And there's a notch here and there's a notch here. Just taking very carefully, slide that bearing down in. Now you want to watch right here. When you put this bearing in, sometimes what will happen is this sharp edge here will actually scrape some bearing material off, and there'll be a little bit of aluminum here. We deburred these really well, so I don't really have any aluminum scraping off of these, but just make sure you get that off of there if you have that going on. Okay, and make sure your notches are lined up, and just basically install all of your bearing on the upper end. This is the upper bearing, which has, of course, the oil feed hole. The oil feed hole needs to be lined up with the oil feed hole in the block. And if you have the correct bearings, they should line up, but you want to visually verify and make sure they're all lined up. Get all your bearings in. This is your thrust bearing. Now, the number 5 bearing on the Chevrolet is a thrust bearing. It's wider and it has thrust flanges on it. This is to control the forward and rearward movement of that crankshaft. So, again, same thing, tang here. Just go ahead and fit your tang in there, slide the bearing in, make sure the oil hole's lined up, and you should be good. Okay, so once you get your bearings in, of course, then you want to put the bearings in the cap. Okay, so this is a 2-piece rear main seal block. Now on this block, we actually have to put the upper portion of our rear main seal in before we lay the crank in the engine. Your rear main seal, this is our rear main seal here. It's going to come in 2 pieces. And there's a lip on this. If you look at this seal, there's a lip right here. The back side doesn't really have that crease or that lip in it. This lip right here goes toward the oil because the oil actually pushes on that lip and forces it up against the crankshaft. So this lip or this crease goes in toward the oil. You don't want to put this in backwards. And this seal, you get a good quality seal. This seal is made by Felpro. They work pretty good. So we want to install this in here. Make sure your lip here is facing the oil. The other half is going to go into the cap, and we'll get to that when we put our caps on. All right, so the next step, I guess, I don't normally lay this over, but I want to get this on camera. Our next step is to lay the crank in here. Now, you don't really want to lay the crank on totally dry bearings, but for the Plastigage process, we don't want a bunch of heavy oil on here, so just put a little dab of WD-40 on the upper bearings. The block's upside down right now, and then we can lay our crank in here. And then, of course, we put a light spray oil on it, water displacing formula number 40. I'm glad the NASA engineer that made this didn't give up at 38 tries, because it's WD-40 because it was his 40th try at engineering this formula, and it's fantastic at displacing water. So our crank is clean, and we're just going to very gently lay our crank onto those bearings with a light coating of oil. Okay, so there we go. So now, the next thing I want to mention here is the Plastigage I talked about. I found Plastigage at AutoZone. Now this package comes with 2 different colors, and it's different size ranges. Our size range is going to be that green Plastigage, and I want to show you this. Take the green stuff out. If you open this package up and you look at that Plastigage, it basically looks like a little piece of green string. Now, the way that this works is you take a piece of that Plastigage and you lay it across the bearing, and then you torque your cap on, and it's going to squish this Plastigage. Once you squish it, you pull the bearing back, the cap back off, and then you just compare the width of that Plastigage. It gives you the range here, and it has metric and it has standard. We're going to use standard. And it compares the range, and whatever width that Plastigage is, that's your in the ballpark of your clearance. So we're going to do one of these, and I'll show you how we do it. So we have our crankshaft in here. We're going to go ahead and do this metal one. I'm going to do all of these. I'm only going to do one for demo purposes. So if you take a look here, I've just laid a piece of that plastic gauge across there, and this is our number 3 cap. So you want to take your respective cap that goes on there, and again, make sure this is straight across. Now, one thing that's really important is you got to make sure that you don't rotate this crank at all when you do this. So we're going to put our cap on very carefully, and we're just going to let it sit right over that plastic gauge. Now again, when you put your caps on, you have to seat them, so just tap on that cap, make sure it's flush, and then you're going to run your bolts down, and you have to torque these bolts to spec. So I ran the bolts down off camera. I torqued them to 65 foot-pounds. For the sake of time, I didn't bother torquing it on camera. Now when you loosen this up, don't use your torque wrench, just use a socket. And again, make sure you don't turn the crank here at all. So we're just going to loosen our bolts up. And once we get those loose, we're going to pull that cap off. You know, we've got all our bolts out. I like to leave one bolt in and just kind of tap on it to break that cap loose like that. So we'll take our cap off, and you can see there's an imprint there. It shows us how much that plastic gauge was squished. So now if we take a look, you can measure it on the crankshaft here, or you can measure it on the bearing. We got a really good imprint on the bearing here. So I'm just going to measure it here, and if I take a look, I just compare which width matches that, and we're really close there to 2/1000ths. If I go to 1.5, it doesn't match. The 1.5 is a lot wider. We go over here, that is our 2/1000ths right there, and we're right at 2/1000ths, which is really good. That's exactly where we need to be. Now you want to go ahead and plastic gauge all of them to make sure they're all even. I have already plastic gauged all of the mains on this, and also we're going to do the same thing on the rods with each connecting rod to make sure it's right. Attention here, guys, is make sure you get this plastic gauge off of here. Our crank's been clean, but I just take my fingernail, try to keep your fingerprint off of it, but I just take my fingernail and I make sure that all that plastic gauge is really cleaned off of there. We don't want to have any of that, because that can interfere with your clearances and your bearing crush and all that stuff. So just make sure that that plastic gauge is really thoroughly cleaned off of your crankshaft. We've got the crank in, everything's plastic gauge and cleaned off, but I just put WD-40 on these. What you want to do is you want to get your engine oil, your assembly lube or whatever, and just add some of that onto each main journal. It's okay to leave the crank in. Just make sure that these main journals are lubricated. You don't ever want this to go together dry. If you're gonna let this sit for a while before you run it, I would recommend assembly lube. We're going to run this engine relatively soon, so engine oil, the crankshaft lives in engine oil, so I have no problem putting engine oil on it. And then of course we're going to go ahead and put our caps back on, seat them and torque them. Make sure the arrow is facing forward. The crank has to, the cap has to go on in the correct orientation. And this is my number 3 cap. I've got it marked. So we'll just go ahead and install the cap and very gently seat it. Make sure it's flush, front and back, and then we can run our bolts down and torque them. Just run them down, get them flush by hand. Alright, so I've got all of the caps on, you guys, and I've got everything torqued to 65 foot-pounds. These 3 extended bolts here are for the windage tray, and we'll probably go ahead and use that since we're putting a roller cam in it. But keep in mind, once these are torqued up, this crankshaft needs to turn freely with no binding. This thing needs to be nice and free. If you have any binding or anything like that, you got something wrong. We plastic gauged all of our mains, and we're right at 2000s, and we got the crank in, and I mean, man, this thing just turns beautiful. That's exactly what you want. Also, the camshaft's turning freely, so we're pretty much home free as far as the cam and the crank goes. Now, also, you want to check your end play. The end play, you can check right here with feeler gauges. I already checked this. We got about 3000s crankshaft end play. The crank has to move back and forth, so make sure you can get a 3000s feeler blade in here. And you can actually pry the crank back and forth with a pry bar, or you can just pull it back and forth this way just by grabbing onto it. And I can actually, I don't know if you can see it, but I can see the movement there. And we were able to get a 3000s feeler blade in here, so that the crank has to move forward and rearward, and this rear bearing is what controls that. So we're good on our end play and our clearances, and that is installation of the crank. Now we're going to start looking at the cylinders and the piston and rod assemblies. Okay, so another thing I want to point out here, guys, is before you actually put your rings on your pistons, it's a really good idea to check the piston ring end gap. The rule of thumb is you want about 0.004 of gap per inch of bore, so a minimum of 16. We've got 19 thousandths here, so I put the ring in and squared it up. One of the things that I like to do is I'll put the oil ring on the piston, and then I just go ahead and, with the ring in there, I just go ahead and run this down until that oil ring catches the bore, and that squares that ring up in there. And the biggest one we're able to get in here is 19. Anywhere between 18 and 20 is pretty good for a 4-inch bore. 16 is minimum for these. I like to run a little extra gap in case the thing gets hot or something. So but just check. I've already checked all the gaps on these, and they're right around 19-20, which is perfectly acceptable for a 4-inch bore. So just bear in mind that you want to do that before you actually put the rings on the pistons. As far as the rod and piston assemblies go, you always want to put your rings on starting from the bottom, oil, second, and top. So the oil ring is usually made up of a 3-piece unit. We have what we call an expander that goes in here. Now on the expander, you just kind of run that over, and you always want to make sure that the ends of that expander are butted up against each other, not overlapped. And then I will look at where that gap is. You can see that, and there is a scraper that goes on the bottom and the top, and these are spring steel, so you can roll them on. So I find this butted area here, and I just go to the other side of it here, to the right side of it, and I start my scraper underneath, and then you can just, once you get that in there, it's going to hold that expander butt joint together and not let it overlap, and you just kind of roll this on around, and you can see this will fit right in there. So now you've got your gap here with your expander, and also there's a top or with your scraper rather, there's a top scraper, so there's another one that goes up top, and I always leave off from here where the gap is on this scraper, and I go over to the opposite side, and this is going to go on top. So we go on top of that expander, and then you just kind of, like I said, it's spring steel, you just roll it on. That oil ring should move as one unit once you get it on there. Now, with the compression rings, do not bend them and roll them on. This is our second oil ring here. Now, you got to look at these real careful. Sometimes they will have the word top on them. That doesn't mean it's necessarily the top ring. This came out of our box, and it is manufactured to go in the second position, which is the second groove. So if we look on this ring here, there is a dot right there on this one. There's a dot. The dot always goes up to the top of the piston. Make sure that you have a set of ring pliers. You don't want to twist these and roll them on. The way that I do it, is I'll make sure that the dot is up, which it is on this one. And then I just push in to where I'm up against the piston, and you just expand that just enough to get it over that piston and onto that groove. So there, we're in our second groove there, and then we do the same thing with the top one. And there you have it. You got both your rings on. Now you can see the gaps are right there. When you put this in, you're going to stagger those. I just stagger them right now. And then also, it's a good idea to put your bearings in your lower end. I've already plastic gauged the bearings like I showed you on the mains. I did the rods too, and the rods have about 1.5 thousandths clearance, so we're right where we need to be. All right, so now we've got the rings on our pistons, you guys, and we got all our bearings in, checked our clearances and our end gap. To put the piston and rod assembly in the engine, I want to point something out here. The piston and rod assembly in most engines has a specific orientation that it goes into the engine. Now, on a small block Chevrolet, the way that the piston and rod assembly goes in is there's a mark or a notch on the front of the piston. If you can see right there, there's a notch right there on the front of that piston. That is going to go to the front of the engine. So let's say the engine is here, the front of the engine is here. So my notch is going to go toward the front, and then on your rod, the connecting rod has a specific orientation too. On a small block Chevrolet, there are bearing notches, those bearing locating notches. There's a couple of bearing notches here. You see that locating notch? And then there's a locating notch here. Those both go to the same side of the rod. So they're both on this side of the rod. The bearing notches on a small block Chevrolet, that's these two locating notches in here, they always go to the outside of the block. So if you were putting this in the engine, let's say the cylinder was here, this is the lifter valley over here, and the outside of the block is here. The bearing notches are going to go to the outside of the block here, and the notch is going to go forward. Now, if I put that on this bank, let's say the bank of the engine is here, my notches here are to the outside of the block. If I go to the other bank and I try to put it in the other bank, I can get it in there, and look, my dot on the front is still to the front of the engine, but what has happened to my bearing notches? They are now on the inside. So that's the wrong bank for that piston and rod assembly. So you're going to have 4 pistons with the rods on in one direction, and you're going to have 4 with the rods on flipped the other direction. So just make sure that when you get this in, your dot on your piston faces forward and your bearing notches are to the outside of the block, not the lifter valley side. And that's how the orientation of the small block Chevy goes. Now that's not true for every engine, so just make sure, if you don't know, that you look it up or get the specs or whatever. Like, for example, a small block Ford, a 302 289. The dot or the notch on the piston also goes forward, but the bearing notches on the bearings actually go to the inside of the engine. Ford decided to do it differently. So you got to make sure you get that right. If you get one of these in backwards, you're going to be in trouble. It's going to make the motor bind. It's going to cause all kinds of problems. So you want to make sure you get that right. So let me show you how we put these in. Now, again, these have been cleaned and they're dry. I always use WD-40 on the rings and pistons. Some guys put oil on here. Now you got to be careful. You don't want a thick blob of oil. I've seen some guys dunk these in a coffee can full of oil and put them in. That is the worst thing you can do to a piston and a set of rings. Here's the problem. If you get too much oil on here, when you fire this engine up, the rings cannot cut through that oil that's between the ring and the cylinder wall. And when the cylinder fires, it will bake that oil instantaneously, and it can actually cause the cylinder walls to glaze in a couple of minutes. It's because you got this baked oil on your cylinder wall. So it's really important that you don't do that. So we just want a light coating of oil. Now, there is a company that makes piston rings called Total Seal. Google or look up Total Seal piston rings. Are located in Phoenix, Arizona. They actually recommend WD-40 on piston skirts and rings when you install them. They are one of the #1 ring manufacturers in the world. They're in every race series on the planet. And they recommend that you take WD-40 and you just lightly oil the skirts and the rings. Now once you get the piston in, we are going to oil up that pin to make sure that that's good. But that is really all they want to see on that. Now on the bearing itself, we're actually going to use engine oil or assembly lube. I like engine oil because I want the crank to feel the way it's going to feel when it's in its natural environment, which is oil. If you're going to let the engine sit for a long time before you run it, you might want to put some type of assembly lube on here. But as long as you're going to run it relatively quickly, engine oil is all you need on these bearings. Also, I have a couple of tools here that I would recommend. And again, I keep talking about Total Seal. They manufacture these. This is a fixed cone ring compressor. Once you use a fixed cone ring compressor, you will never go back to that crappy band type again. These things are phenomenal. So the drawback to these is you have to have a specific size cone for each bore size. So this bore size is standard, which is 4 inches. So obviously on our cone here, if you look at it, it says 4 inches. And then the other thing is this guy here. I got this from Summit Racing. Now this is to protect the crank when you put the piston in. You can use some 3/8 fuel line or whatever you want, or the little journal protectors made by Clevite. I like this thing because it helps to guide the piston and rod in. So this just goes over those connecting rods and over the journal here, and you'll see when I put this in. And it helps to guide the piston in, and it also helps to protect the crank. We're going to check piston to cylinder wall clearance. The way that we do that is we measure our bore. And we did measure the bore. Now the cylinders have been bored 125 thousandths out. So our bore size is 4.125. We need to mic our piston and see what we got here. So we're just going to take our micrometer. You want to mic this skirt in the middle. Now it does matter where you measure this. The skirt varies in size here. According to Trick Flow, I measured from the top down. The measurement that they gave me put me right about in the middle of that skirt. I'm going to go to the middle of the skirt and see what we got. Very carefully mic the diameter of that piston. And I've got 4.121. 4.121, if we subtract the difference, that gives us 4 thousandths piston to cylinder wall clearance. 3.5 to 4 is acceptable on these pistons, so that's good piston to cylinder wall clearance. Now, of course, we're going to check them all. And also, you want to measure your bore size. And of course, we did measure all of our bores on our engine, and we knew what they were anyway, so they were 4.125, which is exactly what they came out to. So about 4 thousandths piston to cylinder wall clearance, we're happy with that. That does fall within the tolerances that Trick Flow requires for this. So we're going to check all those and make sure they're all right on the money. I won't do all that on camera. The next thing is we want to check our clearances between our crankshaft and our oil clearances here, between our bearing and our crank. So that's going to require you to install your bearing down here. And then of course, once the bearing is installed in the big end of the connecting rod here, take this cap off. And you want to do all of these. We're going to do one for demonstration purposes, but you want to check all your oil clearance. These are our Clevite bearings here that we've got. And this is an HN bearing, which is a coated narrow bearing. It's narrower because of the wide radius on the performance crank. So you want to just go ahead and get your bearings in here. And of course, once your bearings are installed, put the cap on in the correct orientation. Remember the bearing tang locating notches, they go to the same side of the rod. So they don't necessarily line up with each other, but they're on the same side. You want to make sure you get these on correctly. And then once you get the cap on here, you guys, you need to torque this to specification. We're going to use a rod vise to do that. I don't recommend you put this in a bench vise. If you don't have a rod vise, it's probably a good idea to get one. So we're going to go ahead and torque the cap on here. And once the cap is torqued on, then we'll go ahead and measure our ID here. And we'll also compare that to the crankshaft. So I'll get this torqued and we'll do that next.
So we want to make sure that we get this in torqued in. It's a good idea to use a rod vise to do that. Then we can compare the inside diameter of our bearing bore here with the bearing to our crankshaft. Okay guys, so we want to measure our crank journal here and get a reading on it. This is our number 1 piston and rod assembly that we just torqued up. So we want to measure the crank right here at our number 1 position. So our crankshaft right here is reading 2.0985. So I've got my mic locked to a fixed position. You can use a vise with soft jaws or something to hold this mic. I like to use this holder here. It comes in real handy. So I know that I've duplicated the size of my crank journal here. So now what I need to do, calibrate my dial gauge based on that specific size right there. So we'll just go ahead and put our dial gauge, the fingers of our dial gauge between here, that we have zeroed out our dial indicator. So what we've done is that we've duplicated the size of our crank journal right here with this on 0. So now if I put the dial gauge, we put the dial gauge in here with this torqued up, we should see our clearance. So we'll go ahead and put this in, go to the smallest point, and if you look right there, this is a 5/10 indicator. I have exactly 2 thousandths clearance on this journal. That's good. 1.5 to 2 is good for the rods. That's perfect. So I'm going to go ahead and check them all off camera. Make sure you get all of your clearances checked on your oil clearances checked on your rods. If you don't check this, you're going to have problems, right? You got to check every single one of them. You got to mic every single journal here, and you got to get each one checked. So I'm going to check each one based on what rod I'm checking. So I'm going to go ahead and check them all, and once we get that done, I'll come back and we'll move on to. So now we've got WD-40 and oil in our piston. So we're going to take the cone. We're going to put the big side of the cone up here. And we're just going to get, now again, make sure that your ring end gaps are staggered. I've got the second gap here, and the top gap is on the other side. And we're just going to get this piston down into, and you got to kind of work the rings in there, and we're just going to work that cone up, and you want to get that piston down inside the cone. You can see we're inside the cone there. And then we can go ahead and put it in our bore. Now remember, our notch on our piston is going toward the front of the engine here, and if you look back here, our bearing locating notch is going to be to the outside of the block here. So the way I like to do this, and again, I've also cleaned the cylinders. I wiped them out with paper towels and WD-40. Make sure that's nice and clean. Just very gently put your piston and rod assembly into your cylinder. Get the skirt started. And once you get the skirt started in there, that piston will slide right in there. Now if we look at the other end here, I'm holding that piston and rod assembly in, and if you look down here, you can see I've got my journal at bottom dead center, and you just go in and you get that started on there. Now I have something to protect the journal, and I have a guide that will allow that to go in. And you just gently tap that into the bore. Best ring compressor ever. Run it all the way down until your connecting rod just goes right over that journal. Then just go ahead and put your cap on. Now again, make sure that that bearing locating notch right there is to the outside of the block. You can see we've got that to the outside. They go to the same side of the rod. Put your rod cap on and torque your rod nuts to spec. In this case, we're going to go to 40 foot-pounds. So torque them up evenly. There we go. Make sure you torque each one as you go. Now, another thing is, once you get it torqued, you want to make sure that the connecting rod moves side to side. It has free movement. It shouldn't be tight. And also, you want to rotate the engine and make sure that you don't have any kind of binding here. This feels really good, and we got movement here. And that's it. That's piston and rod assembly. Now, like I said, I've got the first 4 in. I'm going to do the other bank. I don't feel like I really need to do all 8 of those on camera. It's pretty straightforward. So I'm going to get the rest of them in
and then we'll start buttoning up the bottom end of this thing. Okay guys, so I got the short block together, turn it over real nice, no binding or anything like that. Now another thing that you want to do here is these connecting rods, you want to make sure that you just grab it and pull it back and forth. Make sure that they all have movement. You don't want any kind of binding between the rods. That's actually called rod side clearance, and there's a spec for it. These all have good movement between them, but we're going to check them anyway. The spec is between 10 and 20 thousandths. I usually just take like a 12 thousandths and put it in here on the small block Chevy. Pull the rods apart and make sure that you can get that filler blade in there. Right now that goes in there real nice. It's fitting real nice, no problems. So we got good rod side clearance, and you can actually feel it and see it here. And you want to check all of them. I've already checked them all, so I know they're good. Another thing is your crankshaft end play. Now you can do that with a dial indicator, or you can do it back here. You can see where the bearing and the cap meet here. That's your rear main. We want to make sure we have at least 3 thousandths clearance there, and you want to take and pry the crank forward with a screwdriver or a pry bar. So I've already pried this crank forward, and I should be able to get the correct feeler blade in there. So we just want to go right in between the bearing and the crank right there. This is actually a 4 thousandths feeler blade, and you can see if I slide that in there, it's going in. Okay, so we've got more than 3 thousandths. 4. I put a 6 in there earlier and it didn't go, so that slides in real nice, and we have play there. If you push this back and forth, I don't know if the camera will pick it up, but I can actually see that crank. If you watch right here, I can see that crank moving. If you put a dab of oil, spray oil or something on there, and then you pry that back and forth, you can see that it's squeezing that oil out of there. So we've got about 4 to 5 thousandths end play, which is good. Now you want to make sure that you have that. If you ever put one of these together and you don't have any play here, something's wrong. You're gonna have to take it apart and figure it out. This one feels real good. Our side clearance is good. Our end play is good. Our main caps are torqued. Our rod caps are torqued, and we double checked them. So we're looking good. That's our short block. And like I said, it's turning real nice with no issues. And so we're looking good. All right, so now I want to look at the timing chain set, and then also our rear main seal. All right guys, now on your timing set here, this is our timing set. I recommend that you rotate these so you got a dot on this gear here, and you can see on this one here we've also got a dot. The dots are going to go 12 and 6. I recommend you can make this much easier on yourself. Just go ahead and bring your crankshaft around until your crankshaft dot is at 6 o'clock, right there. So right there, we're straight up and down at 6. Now at this point, don't put your chain on. Just go ahead and put the gear on there and get a couple of bolts in it. And I'm going to show you why. This is going to make this much easier. Okay, so you don't have to torque these at this point. Just get them snugged up, finger tight. And then we want to rotate this gear around until we get to 12 o'clock, because what we want is we want those two marks dot to dot, just like that. Now that puts your piston on the #1 cylinder at top dead center. It does not put it on the compression stroke for the cam though. It puts it in overlap, but that's okay, because that's all we need right there is dot to dot. You could do it with this one at 6 and this dot up here at 6, which would also put us on the compression stroke instead of the opposite stroke, 180 out. But it doesn't matter. It's easier to line them up this way, and they're going to be timed. So then you just take your gear off and you just go back in like you were. Go ahead and put your mark up to 12 o'clock here, and then we just put the chain on, and that's going to put it right back where it needs to be. So if you look at it, so we're off a tooth here. If you're off a tooth, it's okay. Just move it over one till you get those dots lined up. Okay, so those dots are now lined up. Now the torque on the 350 Chevy timing set is 20 foot-pounds. It doesn't seem like very much, but that's what the GM engineers are saying. I've been doing them like that for years. I've never had them come loose. So just go ahead and torque those up to 20 foot-pounds. And you'll notice that they always come back dot to dot. That puts your piston in the TDC, and that is the timing chain installation for your 350 Chevy. All right, now we're gonna look at the rear main seal. Okay guys, so now on the rear main seal, I recommend you get this set if you don't have a full gasket set. It's a Felpro BS 40656. Looks like a lot of BS to me. So, it's got the rear main seal that goes in the housing. Of course, we're gonna take this one out. And then there's another gasket. This goes between the block and the seal housing. So make sure, I've seen guys leave this out and this thing leak like a sieve. So I'll demonstrate how we put this on. Okay, so I got a real tight shot of this because the sun in the background up there is making this hard to see if I pan out. So anyway, this is the back of your motor, and this is the way that I recommend you do it. Use some gasket sealer on the block surface before you put this gasket on. Just cover that whole area. And before you put this on, make sure that that gasket surface is totally clean of any of the old gasket material, because that could cause a problem. And I just spread silicone on the block surface itself. There's a dowel pin here. Go around the dowel pin and just make sure that that block area has silicone. You don't want this thing leaking. And then just take and place your gasket on here. The one hole is bigger and it goes over the dowel pin. It's pretty obvious. And then there's a stud on the other side. Get that up against your block. And then also, before you put your seal on, put gasket sealer on the outer side of this as well. You want to do everything you can to stop this thing from leaking. They don't generally leak, especially when you add silicone, so this is a little extra insurance. Okay, so we got the gasket on with silicone on both sides of that gasket. And you'll notice I've got the new seal in there. You can actually press this seal in with your thumbs. Just get it in there and press it in. It goes in pretty easy. And also you'll notice there's this white plastic sleeve in here. That is very important for putting this on. It makes it much easier. So what you do is find your stud here. Just get this thing over. Get it started in that stud. And you just very evenly slide that onto the seal. And this sleeve allows that seal to go right on. Then we get your bolt, the 3 bolts and the nut in here, torque them up, and you're in business. All right, so there you have it, guys. I got all the 3 bolts and the stud and the nut on there. Got them torqued up, and that pretty much buttons up the bottom end of this thing. Now we got to put our roller lifters in. Now, one thing that is very imperative that I would advise you to do: get some engine oil. This is not a beer. Soak your lifters in engine oil. What you're worried about is on the rollers is you're worried about that roller mechanism down there. Make sure that you soak that roller mechanism in oil. And then of course you just install your lifter right into its bore. I'll put a couple in here. Once you get the lifters in their bores, soak each one, of course. Some guys will put them in and let them soak for an hour. It's not really necessary. Now you got each set of lifters. Now remember, you've got a retainer that goes over that. So you want to make sure you put your retainer on. Once you get all 16 of your lifters in with your retainers, then of course your spider assembly, it's got the 3 bolts in it, and it just goes over each one and holds those in. So we want to get this, each lifter retainer, and then torque down our spider assembly. It's pretty straightforward. Okay guys, so these are the timing gears that we talked about on the front of our small block Chevy engine. And when we set these up, what you want to do is you want to put the gears on, and you can see that we've put paint marks on the locating dots or the timing marks. What you want to do is set this up so that your gears are dot to dot. That's going to get you your initial timing. You're going to get you really close to where you need to be, and then of course we're going to degree the cam in or dial those in to verify that the timing is actually where it's supposed to be. But this is your initial starting point. Get them dot to dot, torque your bolts, and then we can put our degreeing tools onto the engine. So the next thing we got going here, guys, you can see we've got our degree wheel on the front of the engine, and we've got a dial indicator on the piston. We've also brought our piston up to its highest point of travel, and we've zeroed out our dial indicator. In addition to that, we also put our pointer on the front of the engine. It's a fixed pointer, and it is, you can see, pointing right at 0 on the wheel or top dead center. So the top dead center, 0 on your degree wheel, needs to coincide with top dead center over here. The thing is, this is only approximate top dead center. Because the connecting rod, as it comes up to top dead center, has a little bit of dwell in it, we actually have to dial in the top dead center and make sure this is exactly true top dead center, because the rod can be over to one side or the other, and we can be off a couple of thousandths here. We can be off of top dead center a couple thousandths, and that's going to throw our degreeing off when we go to degree this later. So we have to be at exactly true top dead center. Let me show you how we do that. To find true top dead center, what we're going to do is we're going to turn the crankshaft so that that piston goes down in the cylinder about 50 thousandths on our indicator. We're going to go counterclockwise, and so if you watch the indicator here, you'll see we're going to go backwards, so it's moving down. The piston is moving downward in the cylinder now. We want to go to 50 thousandths, but when you go backwards or counterclockwise, 50 is right there, and then I'm going to go back to it. When I go backwards, I want to go past the point a little bit and come back just in case there's a little slop in that chain. So let's fine tune that at 50 right there. Just in case there's a little slop in the timing chain, that'll get it out of there. Then we're going to look at our wheel. So if we read our wheel here, we are at exactly 12 degrees. Remember, we started out at TDC here and we went down in the bore 50 thousandths, so we went down in the bore counterclockwise to 50, past 50 and back to it. So we went past the 50, right back to it, and that drew the piston down below the deck 50 thousandths. And if we read our wheel, we have exactly 12 degrees. Now, the next step is we're going to go back to top dead center and go down 50 on the other side. All right, so here we go. Now we're going to go clockwise, and remember, we're going back toward TDC, and you'll see this indicator, I'm going back up to my 0, and when I get to my 0, I'm at 0 on the wheel here. I'm going to keep going clockwise, and I'm going to go down 50 thousandths in the bore on the other side of top dead center. So I'm just going to keep going. This time I'm going to go right to 50 and stop because I'm going clockwise. There's really not a issue with slop in the chain. So we went right to 50 and we stopped. If we look at our mark here, we are on exactly 12 degrees. So when we went down in the bore 50 thousandths on either side of top dead center, we discovered on our wheel here that we have 12 degrees on this side of top dead center, and when we went counterclockwise we had 12 degrees over here. What that tells me is if you have the same number of degrees on this side and the same number of degrees on this side, that means that your pointer here, when it is lined up with 0, is corresponding with exact true top dead center on that piston. Now, if we had 14 degrees here and 10 degrees over here, that would tell me that I was off a couple of degrees, and I would have to just bend that needle, because really what we're doing here is we're just making sure that our needle is on 0 to pointing at the 0 here when I am at true top dead center here. We're just corresponding those two things. This is the first step when you degree a cam. You can't skip this, because if you skip it and this is off a couple of degrees, all of the degreeing that you do after that is going to be wrong. Okay, so we know based on that our 0 on our pointer is corresponding with exact top dead center on our number 1 cylinder. At that point, you don't even need this indicator anymore. The only reason you have an indicator on the piston is to find true TDC. We can remove that indicator and we're done with it. As long as we don't move our needle, we'll be fine. I want to talk to you guys about another tool, the next tool we use. Now, this is a really handy tool to have if you're going to degree a cam, and it is actually a lifter bore indicator. This goes right into the lifter bore, and they have a rubber seal on here that kind of gets it tight into that bore, so this thing is not going to be moving up and down, and you get a real accurate read on your lifter. And we're going to start with the intake, and you just put this right into your number 1 lifter bore, and it fits in there snug. And then we can actually see the rise and fall of the lifter while we degree our cam. It tells us where our cam lobe is, so it's a pretty neat deal. All right, now that you got to that point, the first thing we want to check is the camshaft lift. So we need to look at the specs of this cam, because really the reason that we're degreeing a cam, there's a couple of reasons. The two main reasons that we degree a cam, number 1, we want to verify that our cam timing is right, and number 2, we want to make sure that we have the right camshaft. Sometimes these cams get misboxed. So the first thing we're going to do is we're going to look at our specs on this cam so we know what we're working with. So this is our cam card specs for our Engine Pro 1730 MC1730 cam. We're going to be using 1.5 ratio rocker arms. We have a valve lift on this engine of 420 and 433. Now we're going to be measuring the lift at the lobe, so we're going to have to multiply our lift by our rocker arm ratio to get these actual numbers, because the rocker is going to, I mean, obviously the rocker is not on the engine, and the rocker is going to multiply the lift that we get at the lobe. And then of course our lobe center line, our intake lobe center line is 107, and our exhaust lobe center line is 117. Now we've got our degree wheel set up on the intake lobe, so we're going to be looking at these numbers right here. We're going to do our intake first, and we need to verify that these numbers are correct. So let me walk you through how we do that. First of all, we're going to do lobe lift and then calculate valve lift. That's probably the easiest thing you're going to do. To get lift, you can see that we have our dial indicator here, and if I move the wheel here I'm moving the wheel and the dial indicator is not moving. What that tells me, you guys, is we are on the base circle of our lobe. On the base circle is we zero the indicator out, and then we're just going to go clockwise in the direction of travel until we get to the highest point, and that's going to tell us what our lift is. So lift is literally how far the valve opens, like you saw in some earlier lessons. So this is our lobe, and right now our indicator is on the base circle down here. What we're going to do is we're just going to rotate the engine until that lifter bore gauge rides the profile of that lobe all the way to the top, because we want to know what the distance is, or we want to know how far that lobe is going to push our lifter. The distance that it pushes that lifter is our camshaft's lift, or it is how far it is actuating that valve. So if we start rotating our crankshaft here and we watch our indicator that's on our camshaft, now it's starting to move. And another thing you'll notice is it started to move right in this area where it says intake open. Our indicator's here, so we want to count and see how much lift we have. So one rotation of this indicator is 100 thousandths, so there's 100, and we keep going, and now we're coming around to 200. There's 200 thousandths of lift. We're going to continue on. 10, 20, 30, 40, 50, 60, 70, 80, 81. 280, 281 lift, somewhere in there. So here's the dealio. We have a 1.5 rocker arm ratio on this engine. So since the rocker arm ratio is going to multiply the lift, we have to take and we're going to multiply our lobe lift by our ratio, and that's going to tell us how much the valve is actually going to open, because the rocker arm is an offset fulcrum and it multiplies that. The small block Chevy has a 1.5 ratio. So what we do is we take our lift that we got, so we're going to say we got 0.280, and we're going to say times our rocker ratio, which is 1.5, and that gives us 420 thousandths of lift. Now, let's go back and look at our spec. And our valve lift for our intake, according to the cam card, is 420 thousandths. When we did the math, we got exactly 420 thousandths. This is important because we need to verify that this is actually the cam that we purchased. Sometimes cams get misboxed. So far, it's looking really good. It's looking like this is the right cam. So we verified that spec right there. The next spec that we're going to look at, we're going to skip duration. We got duration here. We're going to go to lobe center line. And the reason we're going to go to lobe center line is because the starting point for lobe center line is right here at max lobe lift. So here's what we're going to do. We know we're at max lobe lift right now. Lobe center line is going to be the center of the lobe. There's a process for that. So if we look at our cam lobe here, this is our base circle and this is our lobe. Remember, we went from the base circle up to max lobe lift, and right now our dial indicator is sitting right on the tip of that lobe. To get lobe center line, there's a process we use. We come back down off of the lobe 50 thousandths, and then we go back over to the other side of the lobe, 50 thousandths on the other side, and we read the wheel here and here, and then we just divide those numbers by 2, and that tells us our intake lobe center line. So I'll show you how that process works. Okay, so we're at max lobe lift now. We just did that. We got our lobe lift and our valve lift. Now, intake lobe center line is actually, the starting point is at max lobe lift. That's right where we're at. We're at the tip of the lobe. So what we're going to do is we're just going to take, we know we're at the tip of the lobe, we're just going to zero our dial indicator, and now we have a starting point. The first step in intake lobe center line is we want to rotate the engine backwards, and we want to come back down off of the tip of the lobe 50 thousandths. So we're just going to go counterclockwise backwards. We're going to go past 50 on that indicator, and then we're going to go right back to it. Now at that point, we're going to read our degree wheel. Now if we read this wheel and we're using the white numbers, there are 2 sets of numbers on here. For center line checking, you use white graduations. It tells you that on the front of the wheel. And for valve timing, we're going to use the black numbers. So we have 66 degrees. When we came off there 50, we're reading 66 degrees on our pointer. Now we're going to go clockwise, and we're going to go back up to the top of the low, and we're going to go down 50 on the other side. So we're going to go clockwise. So here we go. We're going back up to max lobe lift. We're going to keep going until we get right to 50 this time and stop. Once we get to 50, we're going to read our wheel again. On our wheel, we have 153. So we have our second reading here is 153. We'll put that first because it's a larger number. And then we also have 66. Now what you're going to do with these two numbers is you're going to add them together. So we're going to take 153 and 66 and add them. That gives us 219. Now what we're going to do with those numbers is you're going to divide them by 2, because remember, this is crankshaft degrees. The camshaft turns half the speed of the crank, so we need to find out what the camshaft degrees are to match our spec. So 219 divided by 2 is 109.5. We call that 109 if you're within a half a degree, right? So it is divided by 2 is 109.5 or 109. Now, we have to look at our spec. Okay, now our spec down here, guys, is 107. We got 109. Now I can tell you that with mild cams like this and the less expensive timing sets, it's not that unusual to see this. So here's the deal. If I have a spec on my card of 107 and I'm getting 109 here, what that tells me is that this camshaft is installed a couple of degrees retarded or late. The timing is late. The higher the number on your intake lobe center line, a higher number on your intake lobe center line means you have retarded cam timing. A lower number on your intake lobe center line means it would be advanced. Now on this engine with such a mild cam, being retarded a couple of degrees, we're not really too worried about that, especially since this is a small cubic inch motor that's going into an S10. It's a really light truck. What retarded cam timing does, guys, is it causes your low end torque to diminish slightly, and it gives you a little more top end power. But being off by 1.5 degrees or about 2 degrees is really not going to make much difference. Now there is a way to change your cam timing. You can put an offset bushing in there and you can play with that timing and fix it, but on an engine like this, we're not going to worry about it. We're within 2 degrees. We're right there. We're very close. So we're happy with that. All right, so we've got our head gaskets on. Now keep in mind there's a couple of dowel pins here that locate the head gasket. But one thing you need to make sure you do, whether you use the bolt or the stud, it's imperative that you seal that. I like to use Loctite, not because I don't want them to come out, but because it does a good job of sealing them. So get some good sealer on the threads. Now if you're using screw-in studs, you don't want to over tighten these. Just go down hand tight, finger tight. That's all they recommend. And at this point, we can go ahead and get our cylinder head on here. So you just take your cylinder head and we're going to gently lay it down on the deck of the block. The studs help line it up, and then at that point it's just a matter of getting sealer on your bolts and getting all of the bolts installed here. So put sealer on them, get all the bolts in, and then we're going to torque them to specs. And then of course on our studs here we have washers and nuts that we're going to use. No big issue there. So that's really cylinder head installation, and of course we want to do the same thing on the other side once we get this one torqued up. Okay, so there you have it, guys. This is our 350 build. Now I got the heads on, got them torqued, and I also put the rocker arms and push rods on. Keep in mind that the roller lifter is taller here and it takes a shorter push rod. I haven't actually adjusted the valves yet. So we're going to take our rocker arms, or our slotted rockers, our fulcrums, and of course our push rods, and we're going to put them in here. Now, what you want to do is you want to put some oil or assembly lube on these. You don't ever want to put this, also put some on the rocker studs here. You don't want to put these on dry. And there's a little on the tip of there's a lot of pressure on these components, so we want to kind of get some lube on this thing. And then you just, your push rod in there, just lube up the ends. Now that we've got those in there, and you can see there's actually a hole drilled through here, so we have a lot of play here. There's really not anything holding that, and that's why we have the slot on the rocker here. That's kind of what holds that into place. So you just want to set your rocker down. Now your rocker has a push rod oil feed hole in it. The push rods on these engines are hollow. Oil's fed up through the push rod, and it feeds up through this oil feed hole, and that's how your valve train gets oil up. So just set your rocker down on there, put your fulcrum on. Once you get your fulcrum on there, we want to, of course, run our new rocker nuts that we bought with the self-locking mechanism on them. Same thing, other rocker, go ahead and put it on, put your fulcrum on. This is an intake, and the way you can tell your intake is it's pretty much in line, or it's close to the intake port here. If you go to the other side of the head here, you'll notice there's an exhaust port right over here. So we have an intake and an exhaust. So we'll go ahead and get our rocker nuts on, and you want to run those down. These rocker nuts take a 5/8 socket. Now, another important thing to note is that we need to make sure that our piston is in the right position. So what you want to do is, we're dot to dot here. Where you want to be is, you want your dot, in order for the number 1 cylinder, which is what this is, to be at top dead center, you want this dot here on the cam gear to be at 12 o'clock, which is up here, and you also want the dot or the mark on this gear to be 12 o'clock. So in order to get this piston to top dead center, right now we're 180 out, we're in what we call overlap. You got to rotate this crankshaft till you get this gear at 12 and this gear at 12. So we just take, and we're going to go 1 complete revolution on this thing, which is going to bring the mark on this gear up to 12, which is right there, and it's going to bring them both to 12 actually. So we're at 12 o'clock here, we're at 12 o'clock here with our gears, and now our cylinder, our number 1 cylinder, is at top dead center compression. And that's where we're going to adjust these valves. Cylinder's at top dead center. So let me explain to you what zero lash is. Zero lash means I don't have any of this kind of play, right? I've done this in some other videos, but some guys will tell you, you want to run this down till you can't spin the push rod. That's not correct. You don't want to do that, because when this is at zero lash, you can easily spin that push rod. If you go down, remember, we're going into the travel of the plunger. If you go down till you can't spin that push rod, your valves will be adjusted, but you're going to be way too far into the plunger, and your engine's not going to perform as well. So we don't want to do that. We just want to run down until I have just a tiny bit of play here up and down. I can just barely feel it. So I want to go just a little bit more. I have no play. Now I can easily spin that push rod. See, I can do it with 1 finger. But I have no up and down play. If you go down till you can't spin it, your rockers are going to be way too tight. Even though they will be adjusted, but it's not going to be optimal as far as power output goes, and that's kind of what we're looking for here. Got some play, so we want to run these both down till we just get rid of that play, and now we have I have no play up and down. I have a tiny bit. Just a little more. I have no play up and down, but again, I can easily spin the push rod. So now that we've gotten to that point, now we need to set our preload. So I've just gotten this nut down to the point where I'm just holding the rocker between the plunger and the lifter, and the rocker arm is holding that push rod there with no up and down play. Now, some books will tell you to go a turn or a turn and a half, and again, don't do that if you want to get good power out of this thing. Street rod, I want to go a 1/4 of a turn. But again, even though I free up some horsepower, my valve train will have a little clatter. If you want to get rid of the clatter and still have a decent valve adjustment, you go 1/2 a turn. Same thing on this one, zero lash plus 1/2 a turn. those valves are now adjusted. Now you can see I can push this down into the travel of the plunger. I got plenty of play there, but I have none of this. So I'm just a quarter turn into the travel of that plunger, and I'm not anywhere near the bottom of that plunger travel. That is a good valve adjustment that will perform very, very well. Hydraulic lifters, as long as you got good self-locking nuts, you should never have to readjust these again. Okay, so the next thing is, what do I do next after I get the first one done? That's the question. Well, what you do is you go through the firing order of the engine. Now, the firing order of the Chevrolet engine, we'll just write it right here, not a big deal, is 1, 8, 4, 3, 6, 5, 7, 2. So in other words, that's the order in which the cylinders are going to fire. So it's going to, 1's going to fire, which this is at top dead center compression right now where it's firing. 90 degrees of rotation past that, 8's going to fire, another 90 degrees, 4's going to fire. So in order to get the rest of these cylinders at top dead center compression, all you have to do is rotate your crankshaft 90 degrees and adjust the next one in the firing order. Well, what is 90 degrees, you ask? Well, it's pretty easy to figure out, because what you can do, now we'll look at number 8 here. Number 8 is over here, and this is kind of the way I do it. So number 8 is this 4-cylinder back here, and of course we don't have the rockers on there or anything like that. But I want to position this here, and I'm just going to rotate this engine clockwise with the rotation tool, and I'm going to put my thumb over number 8. So we'll look at the, I'm going to put my finger over the number 8 cylinder. I want you to listen for this. I'm going to rotate this clockwise about 90 degrees. So hopefully you heard that. I'm sure you did. So what's happening is the piston is coming up on compression, and because I blocked off the spark plug hole, we have compression. Then what I can do is I just visually look in there. I take a flashlight, and you just slowly run the engine up until you see the piston. I'm looking in that cylinder right now, and I'm going to run it up, and I see the piston right now is at top dead center. So the piston's at top dead center. I know it's number 8 in the firing order. So what that tells me is this is ready to adjust. I just keep doing that through this order, 1, 8, 4, 3, 6, 5, 7, 2. I go from here to number 4, which is here. And if you do that, you only have to rotate the crank 1 complete revolution in order to adjust the valves. So that's valve adjustment in a nutshell. Hopefully that makes sense. It's pretty simple. I'm going to go ahead and put the rest of these on. I won't do it on camera to bore you, but once we get the valve adjustment done, then we'll look at the lower end of the engine. So for solid lifters here with polylocks, we're going to do, I'm just going to do this cylinder right here, this second cylinder back, because it's easier to see on camera. So what I'm going to do is I'm going to rotate the engine, and I'm going to watch my exhaust valve. Now on this particular cylinder, this is my intake valve, and this is my exhaust valve. So we're going to start with this one. I want to watch my exhaust valve. Right now my intake's open. We're going to rotate that around until that closes. There it goes, it's going down. So we want to watch this, and I want you to watch this push rod or lifter and this rocker right here specifically. Right now it's loose. We got all kinds of lash, which is fine. But we're going to rotate that, and we're going to watch this exhaust here. So the procedure is exhaust valve just starts to open, and then we're going to adjust our intake. So we're going to watch that exhaust. There it goes. You see how that moved? I'll back it off. If you look right here and even right here, you can see that exhaust, boom, it just started to open. At that point, you're going to adjust the intake on that cylinder. Now, the intake is 16,000 on the solid cam, so we want to take our 16,000th filler gauge. So now that our exhaust has just started to open, this is our intake here, we're going to adjust the intake. So we're going to go down. So we're just going to put the feeler gauge in there, and we're just going to run this down until I take up the slack. So that feeler gauge starts to get a little snug. And right now it's pretty loose still, but I'm going to run this down, and with polylocks you can run them down by hand, or you can use a wrench if you want to. But I'm going to go down. Okay, so right there I just got rid of the slop with the filler gauge. Now at that point, then we're going to take our Allen head up here, and we're just going to run that down and we're going to lock it in place, and that's going to give us 16 thousandths clearance here. Now you want to put a wrench on here because you don't want this thing, the outer body of this polylock, to move. We've got it set at 16 thousandths. We want to hold this in place, and we want to run that nut down good and tight. Okay, get that good and tight, as tight as you can by hand, and that'll hold that in place. And then we take and see we're still a little snug here, but we can pull it out, and you see we've got lash. We've got some clearance there. That is our lash for the intake. Now, to do the exhaust on the same cylinder, see this one's loose here as well. We're going to rotate our engine on that same cylinder here, and we want to watch the intake. The intake is a little bit different. We're going to rotate this. The exhaust is going to open. Once the exhaust closes, we're going to get down into overlap, and you're going to see that intake start to move. There it goes. So on the intake, what we're going to do is we're going to open that intake all the way to the top of the lobe travel, and we're going to watch it. Once we get to max lift here, we're going to wait till that starts to drop. If I keep going here, you can see, okay, that lifter started to drop. Right when the intake starts to drop, that's where you want to adjust your exhaust valve over here on the same cylinder. Okay, so this is our intake that's adjusted. Our exhaust, the spec is 18 thousandths, so they need a little bit more clearance because they run hotter. And you always want to follow what the manufacturer says. So we're going to go up to 18 thousandths, which is right there, and we're going to do the same thing. We got clearance here. We're going to put that 18 thousandths in there. And then we're just going to go ahead and we're going to run this down until that gets snug. Now right there I've got resistance on it. So you can see the feeler blade is stuck in there. Now it's not super tight. I just pinched it in there. And then of course we want to hold this from moving. Same thing. We're going to run our Allen head polylock down. And we want to tighten that up. Use a wrench to hold the polylock body. And you want to get that as tight as you can by hand. And then there's our clearance. Okay, you can see we've got clearance there with it's a little bit snug. That is our 18 thousandths. And that's adjusted. So I'm going to go through and do all of the rest of the cylinders off camera. I won't do it on camera because you'll probably die of boredom. So we got the engine flipped over now. We got to look at our oil pump. Now the gasket set comes with this little plastic retainer in it for attaching the stock drive shaft or oil pump intermediate shaft to the pump. The best thing to do with that is take it and throw it in the garbage. Get yourself one of these all steel drive shaft. Melling sells this for about $15, and it's got a steel sleeve up here with a rivet in it. And it just kind of goes onto the pump like this. I don't really like to put that plastic garbage in there. I just feel better with this one-piece chrome moly sleeve here and this high-strength oil pump driver. Then you take your oil pump. Of course, you got to press your pickup tube in. If you're not sure how to do that, just have a machine shop do it for you. Take your bolt, and first of all, we got to set the height of this pickup screen needs to be about a ½ inch off the bottom of the pan. You don't want it touching the bottom of the pan. So what I do is I'll take and just put the pump on the dowel pins, mounts right here, and I'm going to pull this up at an exaggerated angle, farther than I know it needs to be. And then I'm just going to set my pan on there without the gasket, no gasket on the block. Go ahead and take our oil pan, it's been cleaned up. We're going to set our pan on there. Now obviously that's up too high, you can see here, so I'm just going to push it down, use the pan to push it down, get the pan flush up against the block. Then you just want to take and lower your pickup about a ½ inch. So we're just going to go about a ½ inch right there, and that should be perfect. You don't want it touching the bottom of the pan. Once you get that done, then you can just take your pump back off. Now that our height is set here, take your intermediate shaft here, make sure that the end that goes on the pump is here, stick it on there, and just kind of set your pump on here. That shaft will kind of drop down in that hole, but that's fine. put your bolt in, and you want to torque this bolt to 50 pounds. You don't want to over torque this. The threads for this oil pump are actually inside the rear cap, so you only want to torque that to 50 pounds, and then we can start thinking about putting our oil pan. When you put a balancer on an engine, the balancer is keyed on, and there's a keyway here. What we're going to use to put the balancer on, balancer installation tool. Crazy how they come up with the names for this stuff, but this is a kit that you can rent at AutoZone or pretty much anywhere, and I'll show you how you set this up. It's fairly easy. So we have this piece here that goes on the outside, and then we have this long bolt that goes through it. We're going to take and we're going to run this long bolt through the end of this here, and the threads are going to be down here. Now we also have this piece here that threads into the crankshaft. So this is a little hub that threads in to the crankshaft. So this is going to go in here, and the end of this is going to screw into it. So that just kind of holds this in place inside here. So we just screw this in, and then we go ahead and screw that into the crankshaft. That screws into the end of the crank like that. Just snug it up to the end of the crank. It doesn't have to be super tight, just snug it up. And then you carefully take your balancer, and we're just gonna, our key is here and our key's on the bottom, so you want to be careful when you go on here. You don't want to nick any of the threads on the tool. So you just get your balancer up there to where the keyway is, and you'll feel it drop onto that key. Now this is basically a pressing tool. It has a bearing in it, so we want to take the bearing and put that on, and then we have a nut that's going to drive that on there. Get it on as far as you can by hand. Then we take a wrench and we put it on here, because we don't want this to get too tight. We don't want that hub that's in the crankshaft to tighten up, so you kind of want to hold that. And then you take a big crescent wrench, and basically this is a pressing tool, and you just, this balancer should go on fairly easily. If it starts feeling like it's getting really hard or binding up, something's probably wrong. You just run that all the way in so you get that on. One of the things you want to do before you put the oil pan on is you want to take some assembly lube, and you want to oil the pins here. These wrist pins, you want to take, before you put this pan on, and put some assembly lube right on every one of those wrist pins there. And you'll probably have to rotate the motor to get them all, but you definitely want to make sure that you have, the pins are nice and lubed. This is one thing, just a little extra insurance. We had oil on them when we put them together anyway, but make sure that you oil up all of the pins before the pan goes on. As far as the oil pan goes, in your gasket set, in most sets you'll notice that you have two gaskets for the front of the pan. This is the front of our pan here. There's a thin gasket, and then there's one that's considerably thicker. You can see the difference there. Well, to figure out which one you need, you actually have to measure from the pan rail to the center of that there. Velcro does a really good job of explaining that. If you take a look at this, they show you what your measurement should be here and which gasket to use. So if we measure from the pan rail to the center of that and we get 2 1/4, we need to use our thin gasket. If we measure from the center of that and it's 2 3/8, we need to use our thicker gasket in there. So you can use a ruler or a set of dial calipers. I like the calipers. So what I do is I'm just going to take a straight edge or something, I'm just going to lay it right across here. Now we have an inside gauge here on our calipers that's going to give us a reading. So I'm just going to go right to the center of this, and I'm going to run this up until I just touch the bottom of this ruler that's sitting on my pan rail. So I'm going to go up and I want to measure that distance in there. Okay. So I look at this, 2 inch, 380 thousandths. So that's 375 is 3/8, so it's 2 3/8. So according to our paperwork that Velcro gave us, we need the thicker of the two gaskets to go on the engine. You need to make sure you do this because if you need the thicker gasket and you put the thin one on, this thing is going to leak like a sieve when you get it in the car and start running it. If it's the other way around, you need the thin gasket and you put the thick one in there, it probably won't leak, but you're really going to be like probably tweaking your pan and having to pull it in with the bolts, and it might distort the pan and so forth. So you want to make sure you get the right gasket in there. So you also have a rear gasket, which is this one here. It's got the little end on it to receive the end of the gasket. So that's going to go in the back. I like to take and put, I don't like to use a lot of silicone on the pan, so I don't want to get any into the lubrication system, but I'll take a blob of this and put it in each corner, front and back, and then I'll just kind of lay my thicker gasket on there. And the same thing in the back here. I'll put a blob of silicone in each corner, right down in there, and then this thing just slides in there like that. Okay. Now the end of the gasket, which is that piece right there, is going to go right in here, and we have studs in here, so you got to get this in there and get it over the stud, like so. Same thing here, this is going to go over the stud and underneath this thick piece here. So we'll get those in where they go. Put this one on the stud and put it underneath our gasket. Once you get to that point, just push this thick gasket down on top of those two pieces, and I'll also put just a little blob of silicone in each corner because this is where they have a tendency to leak. So we want to make sure we don't have any leaks here. Right where these gaskets meet, let's put a little bit of silicone here, a little bit of sealer. Now at that point, we got everything torqued, we got our pump on and torqued, we got everything set at the height that needs to be, our pump's welded on. Basically we're ready to lay our pan on here. So then at that point, take your pan that has been thoroughly cleaned, of course, and I always like to take and give the pan a shake like this and make sure there's nothing rattling around in there, because if there's anything under this baffle, a washer or something, that could cause you real problems. So make sure you shake this pan really well. Make sure you don't got anything in there. It's just a little safety precaution that I like to take because you never know. So we want to line these gaskets up as good as we can, and then we'll go ahead and we just lay our pan straight down on, get our bolts in, torque everything up, and we're in business. And that pretty much buttons up the lower end of the engine. Once you get the pan bolts on and get everything buttoned up, we're pretty much done. Now as far as the intake goes, we've got our intake gaskets on here. I always like to put a little silicone under the four corners, and then I take some bolts and just lightly hold the gaskets on. I let the silicone set up, and then once those have set up and are in place, then we can go through the procedure of installing our intake manifold. The intake manifold gaskets come with these two little end gaskets here, and that's for the front and the back of the engine. The best thing you can do with these gaskets is toss them in the trash because they're worthless. What you want to do is you want to put a bead of silicone along here, because if the heads of the block have been milled, which we did mill this block, it actually changes the height of the block here, and it can change how the manifold sits here. If you don't mill the block here, which most people don't, and we didn't, then it's going to change the height here, and that gasket on the end could actually hold the intake manifold up off of these gaskets. So what you want to do is you want to take your silicone gasket sealer, and you want to put a nice, generous, thick bead across the front and the back. The other thing is those factory gaskets that go on the end of the manifolds here, they always leak. Every GM small block Chevrolet from the factory ends up leaking out the front and the back of the manifold. Put a thick bead of silicone front and back, you'll never have any leaks. Makes a nice solid barrier. The manifold sits correctly and you don't have a leaking problem. I've been doing it this way for many, many years, and I've never had one of these leak on me. This is our intake manifold and ProForm carburetor. Now this intake was sitting around for quite a while, but we had it wrapped up in plastic, so it should be okay. What you want to do is you want to take your intake, make sure the surfaces are clean. We've got these cleaned off. Take your intake, look at your bolt holes, and you want to set it straight down on there, right down on that silicone.
Once you get straight down on, it looks good, the holes are lined up, and you can start putting your bolts in. Now, on aluminum intakes especially, you want to make sure that you use flat washers on this thing. So we're going to get our bolts in with our flat washers and torque them in sequence to specs. It is a flat tappet hydraulic cam. Now, the thing I want to talk to you about is, well, there's a couple things. Number one, the lifters, because I ran into a situation probably about 6 months ago where I put a flat tappet cam in, I put the lifters in, I did the break-in and the run stand like we're going to do with this. That's another thing is this video is basically going to be walking you through how to break in a flat tappet cam. I'm going to put this thing, finish putting this together. I'm going to show you the oil that we use. I'm going to fire the engine up, and I'm going to show you the process that we go through. The next thing is what oil to use. Well, there's multiple brands out there. I've recently discovered this one. I like Joe Gibbs break-in oil. I've broken in a ton of engines with Joe Gibbs break-in. I've never had a failure with that oil. I've been using this lately, and this is a company called Maxima. If you research them, you can go online and you can research their company and this break-in oil. I've been using this for about 6 months, and it is fantastic stuff. It's high zinc non-detergent. Now, another thing is sometimes you get the zinc additive or the ZDDP additive because you have to have that in the oil to break in a flat tappet cam. But I would caution you, I've seen 3 or 4 cams go flat by putting zinc additive, comp cams additive or whatever in an engine and running it with oil off the shelf from AutoZone or Napa or whatever. And the problem's not the additive. The zinc additive that comp cams makes is really good. It's a great additive and it works. The problem is guys are running that with detergent-based oil. Listen, you cannot do that. You have to have non-detergent oil. What happens is, and most oil has detergent in it. Detergent is just what the name implies. It's soap. It's a cleaning agent in the oil to keep the inside of your engine. The old days when we ran non-detergent oil all the time, we ended up with tons of sludge in the motor, and you don't really want to do that either. But during the first 500 miles, if you're going to run the comp cams additive, make sure you use non-detergent oil. Or you could just get a break-in oil like the Maxima or the Joe Gibbs, or even Lucas has a really good one that I've used that works very well, specifically designed for breaking in flat tap. It's non-detergent high zinc oil, ZDDP content, and you won't have any problems, or you shouldn't. So basically that's where we're at. So I'm going to get, this is going to get the Vortec heads and the Edelbrock Vortec intake package on top of it. I mean, obviously I haven't put it on yet. Now, when installing the lifters, I recommend that you buy a tube of this stuff here. This is assembly lube. It's made by Stay Lube. Call this, it has moly graphite in it. I recommend that you get a tube of Stay Lube engine assembly, the black moly graphite stuff. When you actually install the lifters, and we got to use the right oil and all that stuff, but when you actually put the lifters in the block, and I also coated the cam lobes with this, I recommend that you take this moly graphite, put a big blob of that moly graphite on the bottom of the lifter just like that. And then as you do that, just put them in. I won't make you watch me put them all in. But go ahead and lube up the lifter with some moly graph, because we're going to prime the oil pump. There'll be oil all over in here. But as far as the mating surface of that flat tappet, get a good coating of moly graphite before you put it in your bore. And the other thing is, if you're doing a flat tappet, make sure that the lifters go in the bore real nice and easy. Make sure they're not binding or tight, because these lifters has to rotate. If you get a lifter that goes in tight or it won't move up and down freely, that's a problem. You're going to have to figure out why that's happening and correct that. Sometimes there's a burr on the bore or something like that. The time to actually figure that out is not after the engine's assembled. I always take a lifter before I even assemble the engine, and I run it through all those bores and make sure there's no burrs. And I do that actually before I final wash the block. Go ahead and put moly graphite on all of them. Get your lifters installed. Now make sure if the engine is in this state that you don't turn the engine upside down and dump the lifters out, right? You might want to put your lifters in after you got your heads on. It's up to you. But regardless of when you do it, nice coating of moly graphite is really going to give you a head start on making sure that this cam lifts. Once I get the heads and the intake on this, which is probably going to be like 2 or 3 days before I get back to this, but As far as the video goes, it's going to be like in the next frame. I'll walk you through the RPM range, how to start it up, where the timing should be set, because you got to get the timing right. If the timing is advanced too far during that break-in, you're going to damage the motor. So there's all kinds of things that you got to do. There's procedures that you have to go through to actually break this in correctly. Welcome back, everybody. So I've got the heads on the engine. Now I want to talk to you about this a little bit. I did a video on these gaskets before. Now with the Vortec heads, what you have, 4 bolts on each head. There's nothing in the middle here. This is a Felpro MS 98000T as in Tom. You can pause it and look at that if you want. And what this is an all steel gasket. So the gaskets that come from the factory for the Vortec heads are plastic, and there's no metal in it, it's just plastic. There are some metal rings here, but these, listen you guys, these gaskets are garbage. What I would recommend is you throw these in the trash and you go with this steel gasket. I've done a bunch of these heads now with this gasket. I've never had any trouble with them. So when installing the intake, make sure you get this gasket from Felpro. The heads have been surfaced or the block's been surfaced. The intake is not going to sit right on this gasket. Sometimes this end gasket can actually hold the intake up off of here, and it causes a problem. All right, so I've got all 4 corners with silicone around the water ports, top and bottom of the gasket, and now I'm going to take my silicone and I'm going to run a big thick bead of silicone right here. And all the years I've been installing intakes on small block Chevys, Fords, even big block Chevys and Fords, I've used silicone for most of those years, and I've never had an issue with these leaking in the front and the back. This is our Vortec intake, guys, and again, got the 4 bolts coming up. We got studs in here. So we're just going to take our intake now, the studs acts as guide, and we're just going to set the intake over the studs and let it gently sit right down on there. Now, another word of caution I would give you on these intakes, the torque on these intakes is really light. It's almost so light it's hard to believe. It's about 15 foot-pounds. One thing you don't want to do is over torque these intakes. That's going to cause you a problem. So we want to go ahead and I'll get all the nuts on here, get my one last stud in, and then I'll show you the torque sequence. Another thing that I would advise you, if you ever use an aluminum intake manifold, always make sure you put flat washers under the bolts or the nuts. Now the torque sequence is a crisscross pattern from the center to the outer bolts. And there's only 8 of them, so it doesn't take that long. Now what I'm going to do is I'm going to convert that 15 foot-pounds to inch-pounds. It's a lot easier if you use an inch-pound torque wrench. If you don't have an inch-pound torque wrench, I recommend you get one. It can be pretty hard to do, even with a 1/2-inch drive, or I'm sorry, 3/8 drive foot-pound torque wrench. It's pretty hard to get it down to 15 foot-pounds. So if we take 15 foot-pounds and we divide or we multiply it by 12, that tells us how many inch-pounds we need. So you just got to go 12 times 15. It's 180 inch-pounds. 180 inch-pounds. So we're going to start here. Now what you want to do is run all these down first. I'm not going to go to full torque. I'm going to go in the sequence. So we're going to go in a crisscross pattern from here to here, and then we're going to go from here to here. So I'm going to go back up here, and I'm just snugging these up yet. I'm not torquing them. Just run them all down. And if you want, you can set this for like 130 inch-pounds and then go to 180. Okay, then we're going to come up here, opposite where we were. It's a crisscross pattern. Now we're going to go back opposite in the back side. And again, I'm not full torque. Come straight across. And then we're going to go diagonally up to that last one in the front. Right up this way. So it's basically just a crisscross pattern. You got to pull it down evenly from side to side. I'm going to go back here and I'm going to start. It doesn't matter which side you start on, but I'm going to go to the full 15 foot-pounds. Okay, right there. There it is. Now I'm going to go diagonally across back here. Okay, there we go. Now I'm going to go straight across to this side, and then we'll go diagonally back up to that side. There it is. Crisscross back up here. And now, once this one's torqued, we've got all the inner bolts torqued.
Okay, there it is. Now I'm going to go crisscross back to the very back one back here. I'm going to go straight up on this side. Then I'm going to go diagonally to the back side. There it is. And straight up to the last one in the front. And that's it. That is your torque pattern. Now another thing I would advise you is go back over them, start again, and do it again. Make sure that, because sometimes these will loosen up. See, I went a little bit. Now I'm going to go in the crisscross pattern. Yep. That one loosened up. Come up here. That's good. That's good. I'm going to go diagonally to the front, straight across, and the outer ones are usually tight. These outer ones, they're torqued. So now I go and I check them all. If they're all torqued, you don't really have to go in the pattern. We're just double checking that they're torqued, and they are. See, now that one came loose. What happens is these studs can stretch a little, the gasket can compress. So you just got to go over this a few times and make sure that the manifold hasn't settled or the gasket hasn't compressed. And just make sure that you got that 15 foot-pounds on every one of these. If you notice in the front here, the silicone has all squished out. Just leave it there for now. Same thing in the back. Our manifold is now installed. That's how you want to do it. Make sure you follow the torque procedure, and you also follow the spec for these. The spec is real low on these Vortex. One thing I know for sure, and I've seen guys do it, if you over tighten these Vortex type intakes, the gasket will leak almost every time. So stick with the manufacturer's torque rating and you'll be okay. We're using this Maxima break-in oil, the high zinc non-detergent break-in oil. So I'm going to go ahead, I'll get a funnel on here and get the oil in it. I've got the oil drain plug in, and then I'm going to show you how to prime the oil pump. Engine Master did a really good test with roller rockers, and they wanted to know what was better, roller rockers or stock rockers, or what the difference was. 5,000 RPMs or less, which is what this motor is going to be, and 500 lift or less. They came to the determination that roller rockers are just a really expensive, completely useless upgrade. They do nothing. You get no advantage from those whatsoever. Now back here where your sending unit goes, I've got a gauge in it, and this gauge, this is actually a really cool gauge. It's a Stewart Warner gauge, and it's actually the first, it's a liquid filled gauge, a gauge out of the first street rod I ever had when I was a kid. I kept it. So I just plumbed it here with these fittings into the oil gallery, and that's going to show us if we have oil pressure. This is your oil pump priming tool, and this just goes in and catches the distributor shaft down in there. We're gonna put that on a drill. Time to put the magic in. We're gonna get 5 quarts of this in, and we can prime that oil. If you don't have the distributor in, you can just go right down the distributor hole with that oil. All right, we got all our oil in, and now we're gonna let that funnel settle a little bit, and then I'll show you how we prime this pump. Well, now keep your eye on the gauge here. There it goes. Watch right here, you'll start seeing oil popping out of those push rods. That one there is coming, that one's coming. We got 50 pounds of oil pressure. That's really good, and I'm spinning this, even on high, this drill is not spinning that pump as fast as the engine will be when it's idling. Okay guys, there's 2 minutes, and we've got oil at every single rocker coming up. We got 50 pounds of pressure. We got oil all the way along the other side. So that's really good. That's the way you want it. That's really all you need to do. Now it's important to prime it though before you fire it up, because when you got a rebuilt engine like this, there's nothing in the oil galleries except air. We're just about there. So we've got the engine in the run stand, and I've pretty much got it buttoned up, putting the distributor in, but I want you to look at the timing tab and notice it. What we're looking at here is that is your timing tab there, and if you look on the front of the balancer, I've got TDC marked. That's that mark up there. So you've got your 0 mark on the tab is down here, and then I've got 10 degrees before top dead center mark. And you'll notice I've set the number 1 piston about 10 degrees before top dead center. Now you can do this on 0, but I like to do it about 10 degrees before TDC. So I want you to make a note of that. So right now my piston is just 10 degrees before top dead center on the power stroke. Now we're going to go back and we're going to look at the distributor, and I'm going to show you how to get that in. All right, now I know most of you know this already, but I've gotten so many requests for people asking me how to hook this up and how to set this up. I want to talk about it. So this is your distributor. It has a gear down here that's driven by the camshaft, but it also has a piece down here that meshes with the oil pump. The oil pump shaft goes in here, and this drives the oil pump shaft. So this goes in, meshes with the cam gear here, and also has to drive the oil pump. Now a lot of times when we put these in, I actually have another video called how to install a distributor, and I go through this. A lot of times what happens is you'll get this distributor in and it'll mesh with the gear down here, but it doesn't line up with the oil pump on the bottom, and you'll notice that the distributor won't go all the way in. It sits up about a half inch, and it just won't go down and go flush with the manifold. Well, there's a real simple way to do that, and I'm going to show you that. But more importantly, what I need to know is I need to know, so right now you saw that we have the engine right about top dead center, 10 degrees before TDC. We want this engine to fire initially when we start it up at 10 degrees before top dead center. So since the piston is sitting 10 degrees before top dead center right now, I want my rotor here pointing right at the number 1 spark plug wire when I start this thing up, right? So when I set my distributor up, this is my number 1 here, and I'll mark that before I put it on. That's my number 1. I want the rotor here pointing right at that number 1 plug wire. Well, the cap, when it goes on, it only goes on one way. There's a locating dowel on this cap, and this is just my run stand cap. So the cap goes on, and there's some slots on here. If you look at this, there's a slot right there. That slot coincides with a slot inside the cap. So this guy goes on here, and you'll feel it lock in when you put it on. Right there. It just locked into the slot. So you can see right next to this mounting clamp, there is a small square dowel that fits right there in that square dowel. So it goes just like that, and if you don't have it lined up, the cap's not going to fit right. But when I slide it over and I line up with that square dowel, what you'll notice is the cap pops down on there. So that dowel goes right into that slot right there, and that locates the cap. So the cap goes on, it only goes on one way, it's located. What I need to do is I need to make sure that after the cap is on, when I get the distributor in the engine, this rotor is pointing to my number 1 spark plug wire. So what I'm going to do is I'm going to go ahead and put the cap on, I'm going to line up my dowel, and then my number 1 spark plug is right here. So I'm going to mark that. So I'm just going to go ahead and I'm going to put a number 1 right there. Also, I'm going to mark the body of the distributor right in line with that number 1. So now I know where that number 1 is. Once I take the cap off and put my distributor in, I know just exactly where that rotor needs to be pointing. Now, it doesn't have to be, I know I sound like I'm contradicting myself, but it doesn't have to be exactly on that mark when you install it, because you have some adjustment here. When this hooks into the camshaft and the oil pump, this is going to turn the rotor, but the body of the distributor where the cap is attached moves independently of that. So this thing is going to be locked into the cam gear, right? And I have some adjustment here. So if I get this in and I'm off a little bit, I can actually move the distributor over here and get it right on. This is how you set your timing, by moving the distributor and dialing that in. And we'll put a timing line on and I'll show that to you. But that's the gist of it, guys. You want your rotor pointing very near where that's at, where your number 1 is. If you do it like that, when your engine is on top dead center compression, now you got to make sure it's on the compression stroke. If it's on the exhaust stroke, your rotor is going to be 180 out. Your timing is going to be 180 off. So make sure you're on the top dead center on the power stroke, or the compression, the power stroke. All right, so with that, we're going to go ahead and stick our distributor in the engine and try to get it lined up here. So now we're back here. We've come to the back of the motor, and remember, we have marked our distributor where our number 1 on our cap is going to be. And then now make sure you got this gasket on here, and then we're just going to gently lay that distributor down in. It's always a good idea to put some lube on this gear as well. So I recommend some assembly lube, or at the very least you definitely want to put some oil on this. Lube up that gear because it's going to mesh with the cam gear. And then now, as a general rule on the Chevrolet, once we get this in, the vacuum advance right here is usually going to point at this cylinder right here, not the rear cylinder, but the second one from the back, right, which is number 6. Now I know that my mark is way up here on the front, so I'm going to rotate my rotor, and then I'm just going to, now when it goes in and meshes with that cam gear, as it meshes into the gear, it's going to move the rotor clockwise. So I've got the rotor, my mark is about right here. My mark is about right here, and my rotor is pointing over here because I know it's going to move about that much. Now watch what happens when I get into that gear. Once I get down into the gear, it's going to move. So it moved. Now the question I need to ask myself here is, where this distributor is sitting, can I line this up with my mark, right? And I can. Now that I've got the distributor into that point, you can put this anywhere you want, but if you'll notice down here, we're not flush. You can feel that this is meshed with the cam gear, but what's happening, the reason this is sticking up here is because I'm not lining up with my oil pump shaft that's coming up underneath. So really all you got to do is rotate the motor. I can turn it by hand or I can crank it. I'm going to crank it and you'll see this thing fall. I'm not going to lose my timing or my position because when I crank it, the rotor is going to turn, but the engine's going to turn with it, so it's going to stay timed. So I've got the battery hooked up. All you got to do is rotate the motor. So I'm just going to touch the key. I'm going to hold on to the distributor body here. The rotor is turning with the engine, but the distributor body is not. It's where it needs to be. So I'm just going to rotate it, and what that's going to do, that's going to allow this to drop into the oil pump. And there it goes. I just touched the key and it dropped right in. And that's really all you got to do. So now that you've got that, you can put your distributor hold down on. We're right where we need to be. We can put our cap on and get ready to fire this thing up. All right, so next we're going to talk about how to install a distributor. First thing that you want to do is you want to get the engine to top dead center compression stroke on number 1. This is number 1. The way you can do that is you rotate the engine and watch your intake valve here. We're going to rotate this around until our number 1 valve here opens. So we're probably already pretty close to where we need to be. There's the exhaust closing. Okay, so there's our intake. Our intake valve is opening right there. So we're gonna keep going. We're gonna open that valve up, and then we're gonna let it close. So we're gonna come up. That valve is closing. Now after this valve closes, we just bring our 0 mark around to 0 on our tab here, and you'll hear the compression. I'll put my finger over this hole, and you can hear that compression. So we want to come up to 0 here, and that's going to put us at top dead center on the compression stroke. So top dead center right there is our 0. We're right here, we're zeroed out. So right now we're at top dead center compression on number 1. Now that we have got that located correctly, we can take our distributor. We come around to the back side of the motor, and here's our distributor. Now the thing about the distributor, if you look down here at the bottom of the distributor, it has a male end, and this is actually just a stock oil pump drive shaft. We've actually got one in the engine, the one we put in there. But I wanted to show you this because this is going to be sticking up from the pump. This attaches to the pump down here. And this is what's going to be sticking up. There's going to be a female end here. And if you look at the bottom of the distributor, you've got an end that will fit right in there. So that fits right in that gear. And that is what, when this distributor meshes with the cam gear, that's what drives the oil pump down here. What we need to do is we need to get this into the cam gear, but sometimes when you put this down in the cam gear, this thing doesn't mesh right away. You can actually get into the cam gear here itself, but have this in here like this, and it doesn't actually fall down in there. So the distributor may not fall down in like that, even though you have this gear meshed. Well, there's a real simple way to do that. So we have our engine on top dead center. We know that. So all you need to do, now the distributor basically goes in this orientation here. My vacuum advance is going to point toward the passenger side over here. My rotor on my distributor, since I have this at number 1, what I need to do is I need number 1, it's real easy to remember, points toward the number 1 cylinder. This is a good way to set it up. Drop this in here. I'm not going to go all the way in with it. I got my vacuum advance pointing over here, basically toward number 6, this way. And then I'm going to put my rotor on my distributor, and I'm basically going to kind of point it up toward the number 1 cylinder. Okay, so then I'm going to go right in, and I'm going to mesh with my gear. Now, the chances that you are going to get this lined up correctly in that oil pump drive down inside this thing here is not very good. But I just want to go ahead and locate my rotor so I'm close, because my number 1 on my cap is going to be right here in this area. And so, and of course, I have timing adjustment. Right now, this distributor is meshed with the cam gear. It's meshed with the cam gear. If I were to turn the motor now, turn the engine now, the rotor is going to turn with the engine. So in other words, I've got this set really close to where I want to be as far as where my number 1 is going to be on my cap. And so I have enough adjustment that I can set my timing here once I get the engine running. I can go ahead and rotate the engine now, and this rotor is going to stay timed with the cam. What that will accomplish is if I rotate the engine by hand, it's going to rotate the shaft around so that it falls into the oil pump drive, and you can see a gap here. And what will happen as I rotate the engine, the rotor will move with the gear, and once I get around to where I mesh with the female end on the oil pump drive gear, it'll drop right in. So some people will pull the distributor out and look at the clocking on the distributor and take a long screwdriver and try to move that oil pump and try to get this to drop down in. You don't need to do all that. That's a complete waste of time and effort. That's really not necessary. All I need to do now, since my rotor is where it needs to be and I'm already meshed with my cam gear, what I'm going to do is I'm going to go up and I'm going to slowly rotate the engine clockwise, and you'll see the rotor moving because it's meshed with the cam. And I'm just going to rotate that until I line up with the oil pump drive, and you'll see this thing drop right down where it needs to be. I'm just going to rotate this engine clockwise, and I want you to watch that. Now you'll notice the rotor is turning because it is, of course, meshed with the cam gear. If I rotate this around, eventually, I'm not going to lose my timing. Eventually, and you might want to grab onto this and you kind of push on it a little bit. But if I just rotate this around, eventually I'm going to find that gear. Those gears are going to mess up, and this thing will just drop right, there it goes. It just dropped right down in. Now, I'm still timed because my rotor moved with my engine, and if I go back to number 1 now, my rotor's going to be over here where it needs to be. And that's all there is to it. That's the initial, that'll get you close, so you have timing right here in this area, and you can adjust that timing according to whatever it needs to be once the engine is running. But the distributor is now in, and it's close enough that if I put my wires on, I start here with my cap and I go through my firing order, 1, 8, 4, 3, 6, 5, 7, 2. When I go to fire the engine up, this thing should light right up. It should fire up immediately. And that's all there is to putting a distributor in. It's not, this is something that gets overcomplicated a lot, but it doesn't really need to be.
So I went through the about 25-minute break-in. I brought the idle down to where it's idling, got everything dialed in, and that's basically it for the break-in. I did the break-in with the mufflers on, but once I got it broke in, I took the mufflers off, and I'll fire the thing up and let you hear it just a little bit at the end of this video. Alright, so that's it, guys. I hope you enjoyed this. If you have any questions or comments or anything that I might have left out of this about break-in, just ask.
Where they hit the nitrous right there?
Yeah. What is this right here? Is this like
Coming up, nitrous oxide.
Oh.
They did, what they do here? 379 torque, or 379 horsepower, 370 torque. Not bad for a basic stock engine. Put it on 30.
Sounds about
What
right.
was it before?
8.
It was.
Oh no.
It was
No.
It was at 14. Today the
It better not be 8. That's
Yeah,
No, it was
that's
yesterday.
super.
It was like 9 yesterday.
oh, look at
Yesterday was
that.
bad.
So
So
leaned,
lost a little.
leaned it out and it didn't like it.
That could be the power valve or the accelerator pump. I think the accelerator pump is huge in this thing. So as you
Well, that's-
double in, it just
That's that quick fuel carburetor, right?
right.
Yeah, that's right out of the box we put that on. And they're usually fat out of the box.
It was very.
But it's better to be fat than,
Lean.
yeah, you
Right
get,
there's right on the edge for lean. So that's
Literally can't.
13.
what was it, 13?
Yeah, 13's rather be
Yeah.
12, 8, 13.
It should run good there.
makes
Should have
sense.
made power, shouldn't have lost power.
Beast than anorexic.
All right.
This other jet doesn't want to break loose.
So you guys are doing a jet change, you going bigger or smaller?
We went from 82 to an 80.
So it was way too rich, so we're gonna change the jets and go to a smaller jet.
Well, we had one that was 404. No, that wasn't it. That's too far. No, yesterday we had one that was 404.
Well, 401, 404, I mean, if it's making 400,
Yeah, it was.
400 is that's a threshold. 400 is a lot more intriguing than 392. Once you hit the 400 mark, that's an accomplishment as far as I'm concerned.
I'll have to find that. We haven't messed with timing. We haven't. We're just.
What's the timing set at?
It's basic. It's like 12:28 or something like that. It's not.
That torque line pretty much goes all the way across. We ended up with 432 torque. And right here at 5252 where they meet, the torque is starting to diminish here around 45, but our horsepower is coming up really good. Our horsepower carried all the way over up to about 6,000. It just starts to dip right there, but you know, we're real happy with that.